Hello students, welcome to the class. Today is our day 4 and we will continue with the chapter structure of atom. Now before starting the class, I would like to congratulate all the students who have attempted the DPP, and I have some names here who have scored most marks in the DPP. We have Kanhaiya, we have Ishan Yadav, then we have Uryashi Majumdar and Shagan Sidhu. So congratulations to all of you for bringing the most marks in our DPP. So I will just at the same time take a moment and tell you that please try to attempt the DPPs that we have given on our website. Now coming back to the topic that we were dealing with, so we will do the most important part of this structure of atom chapter, in which we will cover the quantum mechanical aspect and the dual behavior of matter, right? So this is our disclaimer. Now, if I talk about the important topics or the topics that we are going to cover today, so we will see the Bohr's model of hydrogen atom, then the dual behavior of matter. After that, we will see the elementary ideas of quantum mechanics, then the Schrodinger wave equation. So this is the mm, basic equation or the foundation for all of the quantum mechanics that we know today. Then after, we will move on to quantum numbers and their significance. So this will be the most scoring part and the most asked question part for the JEE Mains exam. Then after, we will move to the concept of atomic orbital as one electron wave function. Okay. After that, we will look on to rules for filling the electrons in orbital. So we have various rules, including the above principle, the Pauli exclusion principle. Then we have our say the Hund's rule of maximum multiplicity. So this is our part that we will look upon for the filling of electrons in the orbitals. Lastly, we will see that how do we write the electronic configuration of elements. So these are the topics that we will be covering today. So today's class will be the most important one from the chapter's point of view, which is structure of atom. Now starting with the Bohr's model of atom. So is my voice right now clear? Is it coming at satisfactory level? Is the voice clear right now? So some of you are telling that the voice is low. Is it good right now? Okay. So I hope you are getting my voice clearly. Now moving on to this atomic model. So this Bohr's atomic model is applicable for one electron system. What is the meaning of this? What is the meaning of this one electron system? So basically, these are those species which have only one electron present in their overall atom. So the multi-electron system are not good for this Bohr's atomic model, because Bohr's atomic model did not consider the interaction between the electrons. Okay, remember this point. So this is very very important, that your Bohr's atomic model is very much and relevant for the hydrogen like species. So if you suppose you consider hydrogen, helium plus and lithium 2 plus, all of these three species have only one electron, right? Then moving on further, we have the postulates of the Bohr's atomic model. So the first one is that your electron revolve around the nucleus, but in stationary path, which are known as orbits or energy levels. Now each of the energy level is associated with a definite energy. Okay, and the energy of the orbit increases as one moves from away from the nucleus. Then second thing, suppose your electron is moving around the nucleus in a circular path. Since the motion is circular, so it will have some angular momentum. Now, a very important point is given here, which says that your angular momentum will be equals to the integral multiple of h by 2 pi. What is the meaning of integral multiple? Means this n that you are seeing will always have a value of 1, 2, 3, 4, 5 and so on. Means it cannot be a fraction. Got it? So this is the most important part. Again, I am repeating it. Basically, it's Bohr's atomic model says that your electron will revolve around those circular paths only where its angular momentum, which is mvr, is an integral multiple of h by 2 pi. Means here n value that we will get upon putting the value of angular momentum will be an integer, right? What are the other uh, notations that we have here? We have m, which is the mass of the electron. We have v, which is the velocity of the electron, and r, which is the radius of the orbit. So we know it very well. To calculate the angular momentum, we use this formula v cross r, mv cross r, and n is the orbit number. Now, the third point is energy is emitted or absorbed when an electron jumps from a higher energy to a lower energy level or vice versa. Now, what is the meaning of this? Suppose your electron is in a lower energy level. Now, it gets some energy and move to a higher energy level. So, during this, what do you observe? That your electron is absorbing energy. Opposite to that, if your electron is coming from a higher energy level to a lower energy level, it will emit that radiation. Okay. So two cases are there. First is of absorption for going from lower energy to higher energy, and second is for emission for going from higher energy to the lower energy. Now, how do we calculate this energy? So basically, to calculate the energy of the emitted radiation or the absorbed radiation, we have this formula, which is h nu, or it is equals to hc by lambda. Now, the energy of the photon which is being emitted or absorbed will be equals to the energy difference between the two orbits between which your electron is moving. So it's very easy to understand. If your electron wants to move from a lower energy level to higher energy level, then the energy which is required to do that jump, that same amount of energy will be absorbed or emitted. Clear to all of you? So this point is important because we will use this result later on. Now we can just simply rearrange this and write it as the frequency of radiation absorbed or emitted is equals to delta E by H, where delta E is the energy difference between two energy levels between which your electron is doing its transition. Okay. Now moving on further. Next we have results from the Bohr's model. Now to get with this, what is the basic idea here? We are moving on to the results directly. We will not go on to the derivation since this is a crash course. I will cover the results. So we have different quantities to be calculated for an electron which is revolving around a Bohr's atomic model. Okay, means hydrogen-like species. So we have our radius. We have to know our velocity and energy related to that electron. Now there are some important formulas for that, and you should remember those formulas. So first of all, what we will see? We will see the radius of the nth orbit. To calculate the radius of nth orbit, we use this formula, which is r of nth orbit is equals to n square by h square divided by 4 pi square mke square z, and that is equals to r naught n square z. Now why we have written it as r naught n square z? Because apart from n square and z, all other things that we are seeing here are constant, like h, which is the Planck's constant. Then we have pi, which is again a constant. Then we have the mass of the electron, which is constant, and k is your 1 by 4 pi epsilon naught. And then we have this E, which is charge, which is again a constant value. Now apart from this all, your n square and z are variables. Now what are these called? So these are, n is the number of orbit number and z is the atomic number. Now If you put the value of all the constants, which is h square, 4 pi square, m k e square, you will get this as 52.9 picometer, and it is written as R naught. Okay, it is written as R naught, whose value is fixed, which is 52.9 picometer. You can also write it as 52.9 into 10 to the power minus 12 meter. Next, we can see that how your radius will vary with the orbit number. So it's very obvious what will happen. As your R value will increase, your N value will increase. You can see it directly from the formula that your Rn value is directly proportional to square times the N. Now, if this is clear, we can say that R1 by R2 is equals to N1 square by N2 square, given that you are keeping your Z value constant. Easy to get? Now, one very important thing here. How are we saying that? Can we analyze this thing physically? Is there any physical outcome of this? Yes, it's very simple. So suppose you are increasing the orbit number. So your first orbit would be closer to the nucleus as compared to the second orbit. What is the reason behind it? It is because the radius of the second orbit is greater. Now that same thing is being reflected in this formula as well. So whenever you move from one orbit to another orbit which is of higher energy, the radius of the orbit will increase, and the direct relation says that the radius of nth orbit is directly proportional to square times n. Any doubt in this? Is it clear to all of you? So remember this formula, we will use it in the PYQs also. So can we move further? Okay. Now next we have the derivation part. So I am giving you the idea how this thing is derived. What we do is we take the electron. Now, since the electron is under the influence of your nucleus, it will experience electrostatic force of attraction. Now, for the electrostatic force of attraction, we can use the Coulombic force formula, which is K times the square of the product of the charges divided by the square times of the radius. Now here, we know that what is the charge on electron? It is E. And if we are considering for any element, then the total charge present in the center, which is your nucleus, will be equals to Ze, because the charge on one proton is E and Z is the atomic number, and atomic number is equals to the number of proton. So if we multiply the number of proton with the charge on one proton, then we can get the charge due to all proton that is present. Got it? So we have Ze multiplied by E. So Ze is the charge due to proton and E is the charge due to electron. So this will give you your product of charges divided by R square. So Kze square by R square is your electrostatic force of attraction between the nucleus and the radius. Now you know that every action has its equal and opposite reaction. So if your electron and proton are getting attracted to each other by a force, then the same electron will experience a outward force which is balancing your electron and keeping your electron intact with the nucleus and controlling the circular motion as well. Now in physics we know that this force which is keeping the balance between the inward and outward is the centrifugal force. Now this centrifugal force acts outwards, whereas the electrostatic force of attraction acts inward towards the nucleus. So whenever these two forces, which is Coulombic force and the centrifugal force, are balanced, your electron smoothly revolves around the nucleus. And remember, they both will be equals to each other. Now we have an equation here, plot here, which shows the relation between the radius and your orbit number, as well as the relation between the radius and the atomic number. So as we increase this n square, since r is directly proportional to n square, the r will also increase. Okay. Yes, the r is the distance between your nucleus and the electron. So since it is the radius of the orbit in which the electron is revolving, So this will be of course your radius. Now what about r and 1 by z? So again, the radius is directly proportional to 1 by z, or we can also say it in different way that your radius is inversely proportional to z. But if we plot a graph between r and 1 by z, we will get a straight line as shown here. But in place of that, if we take r and z, you will get a a curve like structure which is showing a decrease with the increase of z. But since here we are decreasing the z value by increasing 1 by z, therefore the r value will also increase. You get my point? So here we are not plotting a graph between r and z. Instead of that, we are plotting a graph between r and 1 by z. So as we increase 1 by z, the r will also increase, and r is inversely proportional to 1 by z. Similar to that, here we are seeing a relation between r and n square, right? So we will not see a direct, or you can say a square relation here, because we have taken n square rather than n. If we had been taken this n here rather than that, then you will see that the r value will shoot up directly. So that is not the case here, because we have taken n square. Clear to you? Are these two graphs clear to you? So it may confuse you, because now you are saying that okay, since this r and n have a square relation, so it must have given a different graph. But rather than writing n, we have taken n square in the axis, so we are seeing a straight line here. Any doubt in this? So anyone who has a doubt in this? So can we move further? Is it clear to all of you? So I will encourage you to just look on the derivation if possible. So the formula which is being used is been shown in the previous slide, and we have seen the relation, and there we have saw that your r is directly proportional to n square and inversely proportional to your z, and that is the reason we are seeing these two graphs. So any doubt in this part? Anyone? Okay. So I hope now we can move forward. So for your notes and all, notes and the crash course and all, you can just see our description given in the link is given there in the description. You can visit that for our DPPs and all, and for the notes of this same lecture. Next is the energy for the nth orbit, for the electron in the nth orbit. Now, to calculate the energy of an electron in the nth orbit, we use the formula delta E is equals to minus 2.178 into 10 to the power minus 18 by n square. 1 by n1 square minus 1 by n2 square into z square joule per atom. So this is the energy difference between two levels of the atoms, right? So this is not your actual energy, this is the energy difference. Now, next, here n is what? It is again the orbit number, and z is the atomic number. How it is derived? So here we derive it by considering that the total energy is the sum of kinetic energy and the potential energy. We know it very well that the kinetic energy for any given substance is calculated as half mv square, and potential energy will be minus kZe square by r. So this is the formula which is used for potential energy calculation, which is 1 by 4 pi epsilon naught product of charges divided by the distance. Since one of the charge is negative and we don't take here the modulus of the charge but the actual charge, therefore we are getting a negative sign in the end. Then if we use this equation, we can just substitute it and find the energy of a single orbit. Now if I ask you, can you derive or can you say that what is the actual formula for the energy of one orbit? So this is the energy difference basically. From this, can you say that what is the energy of nth orbit? Is it possible? If this is the energy difference, again I am repeating my question. So this delta E is representing the energy difference between two orbits, right? So from this, can you say that what is the energy of one single orbit or an electron revolving in an orbit? Anyone? Again I am repeating this. So delta E is what? Delta E is the energy difference between electrons of two different orbits. Okay, so can we use it to calculate the energy of a single orbit? If so, then what will be the formula for that? Okay, so that was hc by lambda. Okay, so that was hc by lambda. But can you derive a formula for energy from this equation that I have given? So suppose this is the energy difference. If I take it for a single orbit, then it would be, suppose I am taking it for n1, then it would be minus 2.178 into 10 to the power minus 18 multiplied by z square by n1, right? So this will be the energy of the first orbit. Okay, similarly we can write it for the second orbit, which is 2.178 into 10 to the power minus 18 by n square z square by, so this will be the energy of the second orbit, and then if we subtract both of them we will get this. Okay, again I am repeating it. So if you want to calculate the energy of a single orbit, what it will be? It will be minus 2.178 into 10 to the power minus 18 into z square by n1 square. Similarly, if you want to calculate the energy of the second orbit, it would be minus 2.178 into 10 to the power minus 18 z square by n2 square. You subtract both of them, you will get this formula, which is the energy difference between two orbits. Now, we have similarly the formula for velocity, which is 2 pi e square kz divided by nh. Again, here we have constants, which are 2 pi e square k by h. If you take this whole constant thing as v naught, we can write the velocity of the nth orbit as v naught z by n. Or we can just calculate by putting the values of this constant, which is 2 will be as it is, then we have pi as 3.14, e as 1.6 into 10 to the power minus 8, that's 19. Then we have k value, which is 1 by 4 pi epsilon naught, and h, which is the Planck's constant, 6.6 into 10 to the power 34 joule second. So if you put the value of all constant, you will get the value of v naught as 2.18 into 10 to the power 18 centimeter per second. Right? So from this formula, you can calculate the velocity of electron in the nth Bohr orbit. Now, we will talk about the limitations of Bohr model. So is there any doubt in this part? Is it clear to all of you? So shall I move forward? Is there any doubt in this question or in this part of the theory? Okay. So I hope you are getting the point of this Bohr's model. Now we will move on to the limitations of Bohr model. Now, talking about the limitations, the first one is it has no explanation for the fine atomic structure. So basically, in a single shell or in a single orbit, there are more energy levels that are possible. And that was seen with the help of the atomic spectra of the given atom. But this thing was not explained by Bohr. He says that all electron which belong to a single orbit will have the same energy. But we know it for sure that within a single orbit we have various subshells as 2s, 2p. Similarly, in 3 we have 3s, 3p, 3d. Right? So this was not put forth by the Bohr. Next, there was no explanation for the multi-electron system. Okay, so for multi-electron system, this Bohr's model was not applicable. It was only applicable to single electron system or hydrogen-like species such as hydrogen, helium plus, lithium 2 plus, and so on. Then after, so we have some effects here which are Zeeman effect and Stark effect. We'll study about them in the higher classes, but these two effects were not explained by the Bohr's atomic model. Lastly, there was no explanation for the three-dimensional existence of atom. So all of the calculations were done with keeping the atom as circular one-dimensional species. Okay. Now, the most important would be the dual nature of electron. So, when we will move forward in this lecture, we will see that how microscopic particle can show dual behavior, means they can behave both as a wave as a part and as a particle. So, this was not taken by the Bohr's atomic model. Now, moving on to that dual nature of matter. So, this concept of dual nature was given by de Broglie. Okay. And the second very important concept was Heisenberg uncertainty principle. Now, this Heisenberg uncertainty principle also put a backlash on this Bohr's atomic model, because Heisenberg uncertainty principle says that you cannot determine the position and momentum of a particle simultaneously, which is microscopic in nature in accurate sense. But according to Bohr's atomic model, the electron circular path was well determined. So basically he was saying that electron will be present there. It was deterministic in nature. But according to Heisenberg uncertainty principle, the position and momentum of an electron cannot be known simultaneously. So the finding of electron was probabilistic and not deterministic. You can understand this thing in a way. Suppose you have a car, right, which is moving in a straight road. Now, if you know the momentum of that car and the current position of the car, you can say that where the car will be in the further future with the help of Newtonian mechanics, right? But Heisenberg said that you cannot know the exact position and exact momentum of electron. Therefore, you cannot predict the exact trajectory of an electron. Whereas Bohr's atomic model was all about telling the exact trajectory. So here the contradiction occur, and hence the Bohr's atomic model was failed due to this Heisenberg uncertainty principle. So we will talk about this in detail. Now starting with the de Broglie principle. First of all, de Broglie said that any moving particle, so irrespective of whether it is microscopic or macroscopic, it will behave both like wave and matter. So basically it will show dual behavior. But the thing was that your wavelength is not that much significant for the case of your macroscopic particle, means bigger particles. But for microscopic particle, it was very much significant. So wavelength of wave associated with moving particle is given by lambda is equals to h by mv. So here what are we relating? We are relating the velocity of a particle with its wavelength. So any particle that is moving with some velocity will always have a wave nature. But the difficulty is that since the mass of that system, okay, the mass of that system is very large of the macroscopic object that you see around, suppose a moving car or a moving bird, due to its high mass, you will see that the wavelength associated with that large particle or that microscopic particle is very, very small. Means it will move in a wavy fashion, but that would not be visible or would not be significant anymore. But for a very small particle like an electron, whose mass is also very less, this wave nature is significant in studying their properties. So what is the lambda here? It is the wavelength and v is the velocity of particle, whereas m is the mass of the particle. Now if you multiply m and v, you will get momentum. Now this momentum is different from what we have seen in the previous part of this lecture. So that was angular momentum, and this momentum that you are seeing here is your linear momentum, which is due to the linear motion of any species. Is it clear to you? Any doubt in this? So I would say that this is the second most important part after your quantum number, which is your de Broglie principle and your Heisenberg uncertainty principle. Okay, now we can move forward. So next is your Heisenberg uncertainty principle. As I said, Heisenberg uncertainty principle says that it is impossible to determine both momentum and position of any subatomic particle or microscopic entity simultaneously. Now, what is the logic behind this? How we are saying that? So, to understand this thing, you must know the basic idea of locating any object. Suppose you want to locate an object, you want to locate your tab, you want to locate your phone. How you will locate it? The light will fall on that tab or that phone or any other object, then it will reflect back to your eyes. Now that reflection goes into your retina, and with that you are able to judge the position of any other object. Now the particle which you are observing, that particle has some size, right? Now the wavelength which is being reflected to your eyes or which is being passed on to your eyes for its visibility, its wavelength must be in the order of that same object. So basically, suppose you are looking at a phone, suppose, okay, so its size must be good enough so that light can interact with it, or you can say its wavelength should be larger enough or should be of accurate sense so that it can interact with the mobile, and then it will reflect back to your eyes. But if you consider an electron, then its size is very small, therefore the wavelength which is required to locate that object is also very small. You get my point? So basically, due to the small size of electron, you have to have a very small size wavelength. Now if you are decreasing the wavelength to that much extent, then what will happen? That energy will increase, okay, because energy is inversely proportional to lambda. So when you apply the appropriate electromagnetic radiation of smaller wavelength onto the electron, then it will be of higher energy, and since electron is very small, an energy of a very small amount can change its momentum. So as soon as that light with small wavelength strikes your electron, then it changes its momentum. So you are able to locate that electron, but its momentum is changed, right? Suppose we take the opposite case. Yes, so we cannot see the electron, the simple light that you are seeing, its wavelength is large, so it cannot interact with a smaller electron. Now suppose we take the opposite case, we take a light which has a larger wavelength. Now a larger wavelength will have a very low probability of locating the electron, so it will have a lower energy, means it will not change the electron's momentum by passing less energy, but at the same time it will not interact with the electron in an accurate sense, so you will not be able to locate that electron. So both cases are kind of creating a problem. If smaller wavelength is helping us to locate the electron's position, then it is changing the momentum. If larger wavelength is helping us to see the electron, to locate the electron without the change in momentum, but due to its larger wavelength, the position is not determined. So basically, overall you cannot determine both of them simultaneously. So this is the logic behind the Heisenberg's uncertainty principle. Now since this uncertainty is put onto a formula, so we will not move on to the derivation and all, but always the uncertainty in position multiplied by the uncertainty in momentum is greater than or equals to h by 4 pi. So basically we will always have some uncertainty present there, rather in the position or in the momentum. Overall the product should be greater than h by 4 pi or equals to h by 4 pi. Now if you put the value of momentum or the formula of momentum here, which is mv, then we can write it as delta p is equals to m delta v. Now why are we moving out this m out of the delta? Because mass is fixed, there is no uncertainty in the mass, it is not possible, okay. So we will write not delta mv but m delta v, showing that there is uncertainty in the velocity and not momentum. Further, if you put the same thing in the above formula, you will get it as m dot delta v delta x greater than or equals to h by 4 pi. Now here, as I said, delta x is the uncertainty in position and your delta p is the uncertainty in momentum. Now this effect of Heisenberg uncertainty principle is that it is only significant for the motion of microscopic object, because for larger objects we need a larger wavelength, and a larger wavelength does not change the momentum. So both of the position and momentum are known, and it is negligible for the macroscopic object. Now on the basis of these two important principles, Erwin Schrodinger gave this quantum mechanical model. So now we will see about this quantum mechanics. So what is the element? First of all, we will look upon to the elementary ideas of the quantum mechanics. So do you have a doubt till now? Any doubt till this part? So we have talked about what? We have talked about the Bohr's atomic model. We have seen the formula and we looked upon the dual behavior of matter and the Heisenberg's uncertainty principle. Now we will move on to the quantum mechanics and then we will move on to the most important part, which is quantum number. So let us talk about this elementary ideas of the quantum number, quantum mechanics. So on the basis of this dual nature of matter and Heisenberg uncertainty principle, Erwin Schrodinger developed a new branch and a very latest and echoing branch of science, which is quantum mechanics. Now what is this quantum mechanical model of atom? What does it say? So it gives us the picture of the modern atomic structure and it is derived from the application of Schrodinger equation. Now question comes, what is Schrodinger equation? How do we understand this thing? So moving on to the Schrodinger wave equation. So Schrodinger wave equation is something which tries to describe the idea of electron with the help of some coordinates and all. So you can think of this wave function. So we are taking a psi, which is our wave function. So this psi is kind of postal address for the electron. Suppose you are writing a post, sending it to your friend. So you will mention that what is the name of the state, what is the name of the district, what is the local landmark, and what is the pin code. So this all things that you are writing here and the name of your friend as well. So all of these things are what? These are kind of providing the address with the help of which your postal address will be delivered. Your postal thing will be delivered. Similar to that, to give the biodata of the electron, from where it is belonging, what is the energy, and all of this data is hidden inside a wave function. So you know what a wave function is. So wave function is basically something which is used to locate the wave. So it is providing a data for the electron. Got it? As simple as that. So simply you will take the wave function as the postal address for your electron. Now this is the thing that we will use. So we will ask this wave function that what is the energy of the electron. It will tell us the energy of the electron. We will ask this wave function what is the size of the orbital, what is the size of the shell. So this wave function will tell us the size and all of this thing. But to ask it, we have to do certain operations of this on this wave function. Now that operation is something which is done by the Schrodinger wave equation. How it is written? So this is the exact formula that we have here. You don't need to mug it up. It is not that much important, but it will give you a base. It says that the double partial differentiation of the psi with respect to position in 3 dimensions plus 8 pi square m by h square, then in the bracket e minus u, then psi is equals to 0. So this is a what? This is a equation and a partial differentiation equation. You know how to solve derivatives, but this derivative is not that much simpler. So whenever we solve a double derivative of this psi, this wave function that we are given here, we get the actual psi, and from that psi we get every data which is related to the electron. Okay, you get my point? So you will not get that much indulged in this Schrodinger wave equation. You will just know the basic concept behind it. So what we have known till now, that is this wave function is the postal address from which we will ask every question. Okay, and it will give you that every answer for the biodata of the electron. We do not need to derive this equation. It is not there in your syllabus, and believe me, it will not help you in the exam as well. Now here m is the mass of the electron, E is the permissible total energy of electron, U is the potential energy, which is minus Ze square by R, and finally we have H, which is the Planck's constant. Now moving on further. Next, this is your important part, I would say. So if you are having a wave function, so that previous function that you saw, it is derived from this simple equation, which is h cap psi is equals to E psi. Now you will ask me, What is this h cap psi is equals to E psi? So this h cap that you are seeing is the Hamiltonian operator. Now what is Hamiltonian operator? I said you that you will ask the wave function about the data of the electron and it will give you. But how you will ask it? So this h cap is the tool. Suppose we want to know the energy of the electron, right? Then we will apply this tool, this h cap, on the wave function and it will give you the energy. Okay, so you can think it of in a way, it is a simple operator. Like we have the differentiation operator. So if you want to differentiate anything, we use the thing d by dx, and like that we have integration operator as well. We have plus minus. So if you want to add two things, 2 and 3, you will use the plus operator. Similar to that, we have a Hamiltonian operator. Now, rather than adding or subtracting or derivative or doing the differentiation, it operates on the wave function to give you the total energy. Okay, so here we have written it the same way. When your Hamiltonian operator operates on the wave function, it gives you the energy of the same electron, which is written as capital E. Now we know that energy of any species is equals to the total of kinetic energy and the potential energy. So similar to the operator of total energy, we have operator for kinetic energy, which is written as T cap, and V cap is the operator for potential energy. So we can just replace this overall energy with the sum of the two energies, which is potential plus your kinetic energy. Got it? Now we will talk about the important features of the quantum mechanical model of atom. So basically what we learned till this part, we saw that we have a Schrodinger wave equation. When we apply that Schrodinger wave equation, we get a complex equation. So further moving in this given formula, it will give you the previous equation that you saw earlier, and from that we get the psi, and from psi we get the data of the electron. But for now it is not important for you. The important part is the result that we get using that psi, which is your quantum numbers, which we will see in the next upcoming slide. Now before moving on to that, we have some important points here. We'll look on to that. We have seen this also. So energy of an electron in atoms is quantized. Why it is quantized? How we are saying that? So you can think it of from the MVR is equals to NH by 2 pi, which is your Bohr's model. So Bohr's model also said that your angular momentum is quantized. Now if your angular momentum is quantized, that means your momentum is also quantized, because mv cross r is calculated with the help of mv, and mv is your momentum. Now if momentum is quantized, that means your energy is also quantized, because energy is directly related to the momentum. So from that we can say that energy of electrons in atoms is quantized. Next, existence of quantized energy level is a direct consequence of the wave-like properties of electrons. Okay, so particle nature is something which is responsible for many phenomena like your electron diffraction and all, but this quantization of energy is coming from the wave nature of the electron. Now comes your important part. Now listen to this very carefully. We saw that we have a wave function, we solve for that wave function and we get the data from that wave function, which is useful for us. Now this is the data that we get. I am not writing the actual wave function because we don't need it. So that was just a background story so that you can get what quantum numbers are. So it is a direct result which we are getting from the wave function. Now what are the quantum numbers and how it tells us about the electron? So this quantum numbers is used to identify the various energy and the levels that are available to any electron. So there are 4 types of quantum numbers that we have. First we have the principal quantum number, which is represented by n. Okay, now this is the same quantum number which is giving you the orbit number as 1, 2, 3 and all. Okay, so do not get confused in this. So it tells us about the position and energy of an orbital. So it's very obvious. We know that we can calculate the energy of an electron using the formula that we saw earlier. Okay, in the Bohr's model, there we saw that we have n in that formula. So if you know the n, which is your principal quantum number, you can calculate the energy. And we also know that radius is also calculated using that n value. So it also needs that n value. So it tells you the distance from the nucleus. So two things are being given from the same thing, which is n. So n tells you about the position and the energy of an orbital, because it is used in the Bohr's atomic model to calculate the total energy and the radius of the orbit. Next, it tells you about the shell number. So that is very obvious. The value of the principal quantum number n is simply the shell number. Then moving on to the next one, which is azimuthal quantum number, represented as L. Now, the value of L tells you about the shape of the subshell. So first thing is the shell. Inside any shell, we have the subshell. Now, that subshell is decided by the value of the azimuthal quantum number. So for example, we have this S subshell, P subshell, D subshell and F subshell. Apart from this, it also tells you about the angular momentum of the electron. So basically, this SPDF you are seeing, this subshells you are seeing, it is the shape. Okay, it helps you determine the shape. So it is also called the orbital angular momentum. Now, how can we find the value of L? So for that, we need to first know that which shell we are interested in, means which is the value, what is the value of the principal quantum number. So for a given quantum number, principal quantum number n, we can have L values varying from 0 to n minus 1. Suppose we are considering it for the first shell, then what are the possible values of L that we can have? So it will be 0 to 1 minus 1. So for first subshell, if you take the n value as 1, so it will be 0 to n minus 1, which is 0 to 1 minus 1. So that will give you a single value of L, which is 0. So for the first shell, we have only one value of L, which is 0. And therefore, only one subshell is possible in the first shell, which is S subshell. Now similarly, 1 is related to P, 2 is related to D, 3 is related to F and 4 is related to G. So can you calculate the number of subshells which are possible, or the subshells which are possible for the second shell? How do we calculate it? We use the same formula, 0 to n minus 1. Then what are the values of subshells that you will get? Anyone? Again, I am repeating the question. So you have to tell that what are the possible subshells for the second shell, means for the value of n is equals to 2. We use the formula 0 to n minus 1. So what are the possible values of L? Anyone? You get my question, right? So I'm again repeating the question. I'm saying that from the, so what are the values of n? What are the values of L that are possible for a given value of n if n is equals to 2? So the two values are 0 and 1, which corresponds to S and P. Got it? Now the question arises, can we calculate the number of subshells or the types of subshells directly from the value of n? Yes, it's very simple. For n is equals to 1, only one subshell is possible, which is S. For n is equals to 2, two subshells are possible, which is S and P. For the third shell, which is n is equals to 3, three subshells are possible, which is S, P and D. Got it? Now moving on to the next quantum number, which is magnetic quantum number. So this magnetic quantum number tells us about the spatial orientation of the orbital with respect to standard set of coordinate axes. So what I am saying here is that now we have subshells, and inside subshells we have orbitals. For example, if we take it for the S subshell, we have only one orbital, which is S orbital. For the P subshell, we have three orbitals, which is Px, Py and Pz. Now different values of P tells us about the spatial orientation of the orbital. Let's see how. So to calculate the possible values of M from a given value of L, how do we use it? We use it as M is equals to minus L to L. Suppose I tell that you are taking the P subshell. Okay, I am taking the P subshell. Then what are the values of M that are possible? What values of M can you take? Again, I am repeating that question. Suppose you have P subshell, right? Then what are the values of M that are possible? Anyone? So there will be 3 values. What are those values? So again I am repeating my question. So for the p subshell, what values of m are possible? Okay, so let me tell you the answer. So for a given value, so I am telling it about the p. So p subshell means the value of L is what? The value of L is 1. Therefore, the value of m will go from -1 to +1. So -1, 0 and +1. Very good. The correct answer will be -1, 0 and +1. So for the p subshells, 3 orbitals are possible whose values will be -1, 0 and +1. So n is, if n is the number of subshells, then how we can calculate the number of orbitals in a subshell? It is very simple. It will be 12 plus 1. So suppose I am calculating it for p, then the p has a value of 1. Therefore, the number of orbitals which are possible will be 2 into 1 plus 1, which is 3. And what are the values of those 3 p orbitals? They have the m value as -1, 0 and +1. Now, we can calculate the number of orbitals in a given shell. Okay, I am telling about the shell. So this above formula that you are seeing, it is about a subshell. So you have a shell. Inside the subshell you have a subshell, and inside the subshell you have orbital. So to calculate the number of orbitals in a subshell, we use the formula 12 plus 1. And to calculate the number of orbitals in a shell, we use the formula n square. Got it? Now, since we have seen that p subshell has 3 orbitals, we represent those orbitals as px, py and pz, and these 3 p orbitals are perpendicular to each other. Similarly, for d subshells, 5 orbitals are possible. Remember the names of those orbitals. They are dxy, dyz, dxz, dx square minus y square and dz square. Similarly, for f subshell, we have 7 orbitals. So I would suggest you to at least remember the possible orbitals of the d subshell. Up till d subshell, you should remember with the name. So I'm basically talking about this symbol representation, which is dxy, dyz, dxz, dx square minus y square and dz square. Now, if you want to calculate the number of electrons, how do you calculate it? So basically, in a single orbital, 2 electrons are possible. So if you know the value of L, that means your subshell, you can calculate the number of maximum number of electrons in that subshell. So since the number of orbital is 2l plus 1, you can calculate it by simply multiplying with 2. So each orbital has 2 electrons, and if there are 12 plus 1 orbitals in a subshell, so total number of electrons that are possible in a given subshell is 2 into 12 plus 1. Now moving on to the last quantum number, which is spin quantum number. Now this is the most interesting quantum number. Why I am saying it? Because from the wave function that we have seen right now, we said that we are able to know the postal address of any electron. Means your wave function tells us everything about the electron, but it is not able to tell us about this spin quantum number. So the value of spin quantum number will not come from the wave function. This is the only quantum number from which cannot be calculated using the wave function. Remember this thing. Now, what is the value of ms which is possible? Two values of ms are possible, which is plus half and minus half. These are representing the two orientations of electrons. Now, these are also called the two spin states of electron, and they can also be represented in writing the electronic configuration as spin up and spin down. So here you have two half hooked arrows, right? One is pointing up and the second one is pointing down. Further, we have a formula to calculate the total spin. How do you calculate it? Suppose you have to calculate the spin, then you will use the formula half into n plus minus. So that will give you the total spin. And similarly, if you want to calculate the maximum number of electron in a main energy level, it is calculated by using the formula 2n square. Now next is the Pauli exclusion principle. Now this principle is something which is used while filling of electron. Okay, how do we say it? So basically it says that no two electrons in a single atom. So I am talking about two electrons which are present in the same atom. So no two electrons in a given atom can have the same value of the four set of quantum numbers. Okay, so it is possible that they will have the value of three quantum numbers same. Okay, but it is for sure that if the two electrons are in the same atom, they will have the fourth quantum number different. Okay, so this is very, very important. Now we will talk about the pairing of electron. So this pairing of electron is directly coming from your Pauli exclusion principle. How? So it says that no two electron in an atom can have the same set of all four quantum numbers. Now from that, if you are saying this thing, then in a single orbit, suppose I am doing it for a single orbit, then if two electrons will have the same spin, then in that case they will have the set of all four quantum numbers same, and that is not which is possible, something which is possible. So remember, in a single orbit, if two electrons are orbital, if two electrons are present, then they both will have the opposite spin quantum number. And next, the p subshell, in case of p subshell, the pairing starts from the fourth electron. In d subshell, the pairing starts from the sixth electron, and for the f subshell, the pairing starts from the eighth electron. Moving on, next, the significance of quantum numbers. So we have seen all those quantum numbers. It tells something about each and every electron, right? But what is the physical interpretation of that? So first, this formula is used to calculate the orbital angular momentum. Since your electron is revolving around the nucleus, it will have some orbital angular momentum, and the formula is h by 2 pi root under L into L plus 1. So if you know the value of L, you can directly calculate the orbital angular momentum. Similarly, you can also calculate the spin angular momentum. How do we calculate it? It is h by 2 pi root under S into S plus 1, where S is the total spin. The formula that we have seen just now for the total spin was half into n plus minus. Okay, so basically you add up all the spins that are present. So suppose 3 electrons are there, 2 are in the up spin, 1 is in the down spin. So if you add the 3 spins, you will get a plus half. So that same value is put here in this formula. Next, it tells us about the shape of the s, p, d and f, right? So it is very clear. If s orbital is present, then it will be of spherical shape. If p is present, it will be dumbbell shape. Then if d is present, it will be double dumbbell. And for f subshell, the shape is very complicated. Now moving on to atomic orbital and wave function. So till this point, is it clear? So we have talked about the quantum numbers. If you have a confusion, you can ask it here. Any doubt till this point? So do you have a doubt till this point? So now we'll talk about a topic which is important from your JEE advanced exams, right? So this quantum numbers is asked mostly in your JEE mains, and this plot is something which is important for your JEE advanced exam. So it is, so this point it is it clear to you? Any doubt till this point? Okay. So now we will move to this wave function part. Yes, the Schrodinger wave equation is not that much important. You don't need to mug it up. You just need to remember this quantum number. Okay. Now, what are atomic orbitals? So we have seen about atomic orbital just right now. It is the place where the probability of finding the electron is significant. Okay. Now this atomic orbital is something which is directly related to the orbital wave function. Now, what is wave function and what is its significance? So I told you a lot about this psi, that this psi is used to calculate is used to know the postal address of the electron, the energy, the shape and all. But what is this psi? What is its actual physical significance? So that was something which is derived from the psi. What the psi means itself. Now to understand that thing, you should consider two things here: psi and psi square. So it is a very important line. You should remember this, that psi has no physical significance. Means, suppose I am telling a word such as dog, right? So when I tell a dog, it has a physical, I would say, interpretation, which is a dog which is moving here and there. It is an animal which has four legs and all, right? So it has a physical significance. Now suppose I tell good, okay, or if I tell some feeling or something like that. Now that thing is not an object. It has no physical interpretation. Now similar to that, psi is something which tells us about everything about electron, but there is no physical interpretation of that psi. Means it has no real evidence, right? But if you take the square of that same psi, it tells something which is related to the physical observation of the electron. What is that? So for that, let us look at the diagram here, which is the plot. Okay, so I have plotted psi and psi square for both 1s and 2s. So if you look at psi versus r graph, so the first graph which is between psi and r for 1s, and the second graph which is psi and r for 2s. Here we have two things that we need to notice. If you look for the first graph of 1s, then both the graphs, psi versus r and psi square versus r, for both the graphs, 1s gives the same plot. Okay, 1s is giving you the same plot for both the graphs, whether you see the graph of psi versus r or psi square versus r. But when you move on to 2s, the psi versus r graph and psi square versus r graph are not same. They do not look like same, because here you can see that the line or the plot is going below the 0 point or going on to the negative. Now if I take suppose the psi square, it is not going on to the negative part, rather than that it is moving upward. And it is very obvious, since we are taking square, square can never be a negative value, right? And psi is always a something which will give you a positive or a physical interpretation. Psi square will tell you about the probability of electron, right? Suppose if I take psi as the probability of electron, then we see that the graph is going below the 0 point, which tells that probability is negative. Now this is something which is never possible. Therefore, the down graph, which is psi square versus r, it is telling about everything about the electron, because it has no negative part. Rather than that, since it is squared times, so it is going up. Got it? Is it clear to you? Is it clear to all? Okay. So again I am repeating it. Psi has no physical significance, whereas psi square has physical significance. You can understand this thing by looking at the graph that is given here. So basically, if you look upon the graph of psi versus r of 2s and psi square versus r of 2s, the psi square versus r is always showing a positive plot, whereas psi versus r is showing you a negative plot. And the probability of an electron can never be negative. So that is the reason your psi square has a physical significance, whereas your psi has no physical significance. Now one more important point here. For both of this graph, you are seeing a 0 point. Now since psi versus r has no physical significance, we can look on to the next graph, which is psi square versus r. Here your graph is going to the minima. This minima is something which is known as node. What it is known as? It is known as node. So here the probability of finding the electron is minimum. So a new definition comes into the picture. A node is a place or a region where the probability of finding an electron is minimum. Okay. Now the definition goes as node is a region of space where probability of finding an electron is 0, or you can also tell it as minimum. So there are different types of node, and we can calculate the number of nodes for every orbital that we know. So for different subshells, we have different count of nodes. For example, we have radial nodes whose value is calculated using the formula n minus L minus 1. Okay, so n is the principal quantum number and L is the azimuthal quantum number. So this is the formula to calculate the radial nodes. So there are two types of node, remember. First is the radial node and second is the angular node. And how do we calculate it? It's very simple. Whatever is the number of L, that is the number of angular node present in the particular subshell. So if you want to calculate the number of nodes in a particular subshell, then two types of nodes are possible there. First is radial node, whose formula is n minus L minus 1, and second is angular node, whose value is simply L. Okay, so whatever be the value of L will be the number of angular node present in a subshell. For example, if you take P subshell, so P subshell has a value of L is equals to 1. Therefore, the number of angular nodes present there will be 1. Okay. Suppose if we take 2P, then again the number of angular nodes will be 1. But if you take it for the radial node, your radial node will also depend upon the value of n. Suppose if you calculate the number of radial node for 2P, what will be the value? What will be the value of your angular node? Sorry, your radial node for the 2P subshell. Similarly, try to calculate it for 3P as well. Again, I am repeating my question. You have to calculate the number of radial node for the 2P subshell and for the 3P subshell as well. Anyone who can solve this? It's very easy. And questions are asked from here directly. And you will easily secure marks in this. Anyone who has a doubt in this? So again I am repeating my question. So what will be the number of radial nodes for 2P subshell and for 3P subshell? You can just comment it here. So for your DPP and notes and for attending the lecture after the class, you can just move on to the description part of this video. From there you will get the link for each and everything. So anyone who is willing to give the answer? So what is the number of radial nodes for 2P and 3P subshells? So it's very easy to calculate that thing. Okay, so let me do it for you. For 2P subshell it will be 0, because for 2P subshell the value of n is 2 and value of L is 1. So 2 minus 1 minus 1 is 0, and for your 3P subshell that value will be 1. Okay, clear? It's very easy to calculate. You can try it by yourself as well. Now with this we will move on to the total number of nodes. So what will be the total number of nodes? It will be addition of both of them. So n minus L minus 1 plus L, that will give you n minus 1. So total number of nodes present in any subshell is calculated as n minus 1. Yes, Niranjana, very good. The correct answer will be 2P will have 0 nodes, 0 radial nodes, and 3P will have 1 radial node. Now last we will move on to the filling of electrons in orbitals. So there are some rules which are given here which is used for the filling of orbital. First is Bohr principle. Bohr principle says that electrons are filled from a lower energy level to a higher energy level, means in the increasing order of energy. So how do we compare the energies of two orbitals? Very simple. The one with the lower value of n plus L will have a lower energy. In case they have the same value of n plus L, we compare the n value, right? Now if you do that thing, if you use that thing, you will get a order which is given here. So it is directly from the NCERT figure 2.17. So we start from 1s, then the next lower energy is 2s, then the next lower energy is 2p, then 3s, then 3p, then after 3p we have 4s, then we have 3d, 4p, 5s and so on. You can simply calculate the value of n plus L, and once you know the value of n plus L, the one with the larger value of n plus L will have a higher energy, and one with the lower value of n plus L will have a lower energy. In case the n plus L value is same, you will simply compare n values. Now moving on further, the next is for the hydrogen atom. Now this energy order that you have just seen right now, it is not applicable to hydrogen like species. So for hydrogen like species which have only one electron, this is the energy order, which is 1s is less than, then we have 2s equals to 2p, which is less than 3s equal to 3p is equals to 3d, and so on. So basically here the value of n, which is the principal quantum number, is itself the deciding factor. There is no role for L in case of hydrogen like species, and that is the reason we are seeing this order. So you should remember this is very very important, and questions are asked from this point of view also. Got it? Now next, moving on to the Hund's rule of maximum multiplicity. It says that electrons will never pair up until each and every orbital of a given subshell are filled singly. For example, if we take the 2p subshell, first of all 3 orbitals are present there, 2px, 2py and 2pz. So first 2px will be occupied, then 2py and then 2pz. Once it is occupied singly, then and then only the pairing of electrons will take place. So that was the reason the pairing of electron is seen from the 4th electron of the p subshell. Similarly for the 5th, so hydrogen like species stands for those species which have 1 electron. Like we have hydrogen, which is simply a hydrogen like species. Then we have helium plus. So if you remove 1 electron from helium, we will get a single electron in the whole helium atom, and that is also a hydrogen like species. Similarly, if you take lithium 2 plus, by removing 2 electrons, it will also have 1 electron, which is a hydrogen like species. Now moving on to the last part, which is electronic configuration. Then after we will do questions. So arrangement of electrons in various shells, subshells and orbitals terms the electronic configuration or forms the electronic configuration of any element. Now how do we write it? So we write it in the form of NLX, where n is the order of shell or the shell number, L is the subshell, X is the number of electron present in that subshell. Now for example, if we take carbon with a 6 atomic number, so 6 electrons are there, electronic configuration will be 1s2, 2s2, 2p2. Okay. Similarly for the sodium atom, we have 1s2, 2s2, 2p6, 3s1. Now we have a very important point here, which is extra stability of completely filled and half filled orbital. It is seen that half filled and full filled orbital are comparatively more stable than single means unfilled orbital, right? So this is the very important point that you should remember, because it creates anomalies in the electronic configuration. So it is seen that in the case of half filled or full filled orbital, the stability is more, and this is seen in the case of D and F most dominantly, not in the case of S subshell. It is seen somewhat in the case of P, and it is seen dominantly in the case of D and F. Now suppose we take the case of chromium. The chromium has an outer configuration of 3d5 4s1. The original one should be 4s2 and 3d4, but it is not in that way, because the 3d5 4s1 has a half filled d orbital. Okay, similarly it is 3d10 4s1 and not 4s2 3d9. So this was all for the theory part. Next we will do the question part. So if you have questions, you can just comment it down here. I will answer you as soon as possible. So here is your first question. The question is asking us to tell the energy which is required to stop the ejection of electron for copper plate, which is having a work function of 0 to 0.24. Now the radiation which is being radiated on the metal is 253.7 nanometer. Okay, the work function is given here. Okay, you have to tell the correct option. So again I am telling it, the stopping potential is given as 0.24 electron volt. The wavelength of the radiation is given as 253.7 nanometer, and you have to tell us the what? You have to tell us the wave work function of that particular metal. Now, what is stopping potential? Suppose you ejected an electron from a metal surface. Then the energy which is required to stop the electron from moving is known as the stopping potential. And of course, that energy will be equal to the kinetic energy of the electron. Means the same amount of energy with which it is moving, you have to apply that same energy to stop the ejection of electron, and that is known as stopping potential. Now for that, you have to know the formula which is for the photoelectric effect. The correct answer is A, which is 4.65. Now how do we solve it? First of all, if you talk about the energy of the photon, then any photon which is being striked on a metal surface, then its energy is used in two ways. First of all, it is used in plucking out the electron or removing the electron, which is known as the work function. And the second thing is used in the kinetic energy of the electron. Now, if you write it in terms of mathematical way, we will write it as W plus EV naught. W naught plus EV naught. Here E is the electric charge and the V naught is the stopping potential. Now next, EV naught is equals to the kinetic energy which is required to stop the ejection of electron, or and so known as stopping potential. First we calculate the energy of photon, put the values of h, c and lambda. You will get it as 4.89 electron volts. Okay. Now we know that the energy of photon is 4.89 electron volt, and it is also given what is the energy which is required to stop the electron, or you can also say what that is the energy which is related to the kinetic energy of the electron, which is 0.24. If you put all the values here, you will get your work function as 4.65 electron volt. Moving on to the next question. When an electron is excited from the ground level to the fifth orbit, the number of spectral lines observed in the Bohr spectrum of hydrogen atom is. So four options are there. So we have talked about this formula yesterday. I will wait for a while. So just give the answer. What is the correct answer for this? Anyone? So we have seen the formula for the same question yesterday. What is the answer for this question? How do you calculate the number of spectral lines? So it's a very easy formula that we have seen yesterday if you have attended the yesterday's class. Okay, so let us move on to the answer. So the correct answer will be C. What was the formula that was used? It was n into n minus 1 by 2. So the number of spectral lines from ground state is n into n minus 1 by 2. So if you put the value of n here as 5, you will get it as 5 into 4 by 2, which is equals to 10. Right? So this is your formula. Yes, very good. So C will be the correct answer. Now moving on to the next question. How many times does the electron goes around the first orbit of the hydrogen in 1 second? Means you have to see that how many cycles are there in per second. So this is a very good question, and if you don't know how to answer it, just be with me and try to understand how it is solved. Okay, you get it. If you get it how it is solved, then very good. I will discuss this in detail, right? So starting with the solution, the correct answer is first of all 6.57. You can solve it before me. This will be your answer, 6.57 into 10 to the power 15. Now, how do we solve it? So first of all, for hydrogen atom, the velocity is calculated using this formula, which is 2 pi e square by h, and the radius of the first orbit is calculated using h square by 4 pi square me square. Now, we know that circumference of the first orbit is 2 pi r1. Therefore, we can just write r1 is equals to h square by 4 pi square me square. If you put all of this, you will get your circumference of the first orbit in terms of h square by 2 pi me square. Now, what we do next is to calculate the number of rounds by electrons in the first orbit. How do we calculate it? By simply dividing the velocity by distance. You know it. Distance per unit time is velocity. Then if you divide the distance by velocity by distance, what you will get? You will get the number of rounds per second. Okay, so this is the way you calculate it. Again, I am telling you. So this is basically the 1 by time. Okay, 1 by time, or the number of cycles per second, which is the frequency. So here it is asked to calculate the frequency in a way. And to calculate the frequency, we take the reciprocal of time, which is speed by the distance. 2 pi r is the circumference, which is the distance, and v is the velocity. Got it? Now, if you put all of these values here, which is 2 pi e square, 2 pi me square by h into h square, what you will get? You will put all this value and you will get the value of your velocity as, rounds per second as 6.57 into 10 to the power 15. So you get my point. So here we are calculating the frequency, and frequency is reciprocal of time. To calculate the reciprocal of time, we will simply use our simple formula, which is velocity is equals to distance per unit time, and per unit time is equals to velocity by distance. Okay. So velocity is v1 and distance is the circumference, which is 2 pi r1. So this was all for today's class. I hope you enjoyed the lecture. In few minutes, our next faculty will join you. Thank you for joining the session. So do you have a doubt? You can ask it. So anyone who has a doubt in this? Okay, thank you.
Hello everyone. So welcome to day 4 of crash course. So today we'll cover sequence and series. So at first we will do trend analysis for chapter sequence and series. So according to last 5 year, the chapter weightage for sequence and series is 8.51%. Okay. So for exam point of view, this chapter is very important. And for if you do year wise analysis, so in the year 2024, total 2 questions come from the chapter sequence and series based on AP. Okay, and the type is average and easy level. In the year 2023, total 3 questions come from the chapter sequence and series based on sum of AP, term of GP, and sum of AP. That is of easy and average level. In the year 2022, 1 question of average type come from this chapter based on sum of nth term and sum of geometric progression. In the year 2021, 1 question come from the topic arithmetic progression. And in the year 2020, total 2 question come from sum to n terms of AP and sum to n terms of JP. And in the same topic, in the year 2019, total 4 question come. In year 2018, total 2 question come from the topic arithmetic series and sum of n terms of GP. And in the year 2017, total 2 question come from AP based on simple formula, that is 2b is equal to a plus c. Okay. So in today's class, at first we will explain the definition of sequence and series, and also explain what is the difference between sequence and series. Then we will cover arithmetic progression, that is AP, what is arithmetic mean, which is represented by short form AM, and at the last, at the theory portion, we will cover geometric progression, GP. So at first, we will cover some definition, that is, what is sequence? So sequence is list of number. If there is number and we just list them, that is a sequence. And that is arranged according to some definite rule. Okay, so there must be there is a defining rule so that we can arrange the number in a list, and that list is called sequence. Okay, we can also define sequence as a function. So sequence is a function whose domain is a natural number or some subset of natural number like 1, 2, 3, dot 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 k. So this is a subset of natural number. So we can define sequence as a function whose domain is a natural number and codomain is any set. Okay, so if codomain is also a natural number, so this is a natural sequence. Okay, so one important thing is, for a sequence, domain is always a natural number and we just assign a number to a natural number. Okay, so for example, sequence A1, A2, A3, dot dot dot, AN, dot dot dot. So here, this is a sequence, how we represent a sequence. We just separate the terms by the commas. So here A1 is the first element of the sequence, then A2 second element, A3 third term, dot dot dot, AN. So AN is the nth element of the sequence. And when we express this sequence as a sum of this number, that is A1, plus A2 plus A3 dot 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 plus N dot dot dot. This is called series. So sum of elements of the sequence is series. Clear? Now, what is progression? So, if the terms of sequence follow a particular pattern, then this sequence is called progression. Okay? So, progression is nothing but a sequence where the terms follow a certain pattern. There must be relation between two terms. Like if you take example 2, 4, 6, then there is a relation between this first and second term. Okay? And that's if a sequence follow a certain pattern, then that is called progression. Okay? So, let's learn about arithmetic progression. So, what is arithmetic progression? So, it is a progression, so it must be a sequence, okay, with us where its terms follow a certain pattern. So, arithmetic progression is a sequence in which the difference between any two consecutive terms is always same. Okay. So, what is the pattern between the terms? That is, the difference between two consecutive terms is always same. So, we can write the AP as A plus D, A plus 2D, A plus 3D, and so on. Okay. So, this is your AP. So, here, if we take two terms, first two terms, A and A plus D, that is your consecutive terms, and the difference between this both terms is D, A plus D minus A, that is D. Okay. So, this is your AP. And the difference between any two consecutive terms, like if we take the third term and fourth term, that is A plus 2D and A plus 3D, then the difference between them is D. Okay. The first term is A and D is the common difference. So, the nth term of the AP is given by this formula where Tn represents your nth term. So, Tn is equal to A plus n minus 1 D, where A is the first term, D is the common difference for AP. So, by this formula, we can find the nth term of AP. Okay. Now, to find common difference, if we have the nth term and n minus 1 term, so when we subtract them, so Tn minus 1 gives the common difference for AP. D is equal to Tn minus Tn minus 1. So, the difference between any two consecutive terms gives you common difference of the AP. Now, the nth term from end, if we want to calculate the nth term from the end side of AP, then it gives by the formula Tn is equal to L minus n minus 1 into D, where L is the last term of AP. Okay. And if you want to sum the first n terms of the AP, then the summation is represented by the term Sn. So, Sn is given by n by 2, 2a plus n minus 1 d. So, this is the formula for summation of first n terms of AP. And is also equal to n by 2 a plus L, where L is the last term. So, how we get this? If we write 2a plus n minus 1 d as a plus n minus 1 d, so the formula of L is a plus n minus 1 d. So, we get n by 2 a plus L for the summing first n terms. And if we know that what is the sum of first n term, then we can calculate the nth term by using Sn. So, nth term, that is Tn, is given by Sn minus 1. Sn is the sum of first n term and Sn minus 1 is sum of first n minus 1 term. Clear? So one important note, whenever you are asked to take three terms of the AP, we can choose A minus D, A plus D. So these are three terms of AP, and the difference between two consecutive terms is D. If you take first term, that is A minus D, then A, then difference between them is D, and last two terms A and A plus D, then difference between is D. So whenever we are asked to take three terms of an AP, we can take A minus D, A and A plus D, where A is the first term of AP and D is the common difference of AP. And for four terms of AP, we can take A minus 3D, A minus D, A plus D and A plus 3D. So this is an AP, and here the common difference between the two consecutive terms is 2D. So that's how we can write four terms of AP. In case of five numbers that are in AP, they can be written in the form A minus 2D, A minus D, A plus D and A plus 2D. The difference between any two consecutive terms is D. Okay. If three number A, B and C are in AP, then the second term can be written in the form of first, successive and preceding term, like 2B is equal to A plus C. And if 2B is equal to A plus C, then the number A, B and C are in AP. Clear? So let's look an important result on AP, that is in a finite AP like A1, comma, dot AN, then the sum of the terms equidistant from the beginning and end is always same and equal to the sum of first and last term. That is A1 plus AN is equal to AK plus AN minus 1 n minus k minus 1 for all k is equal to 1 2 3 dot n minus 1. What is mean? There is an AP A1 to AN, and if we the sum of terms equidistant from the beginning, so if it, let's take k is equal to 2, so A1 plus AN is equal to, the value of k is 2, so A2 plus AN minus 2 minus 1, that is AN minus 1. So the term A2 from the beginning and AN minus 1 from the end, that is equidistance. So the sum of A2 plus AN minus 1 is equal to A1 plus AN. Okay, if we take k is equal to 3, so A3 plus AN minus 3 minus 1, so 2. So A3 plus AN minus 2 is always equal to A1 plus AN. So sum of the terms equidistant from the beginning and end is always same and equal to the sum of first and last term. Clear? Now, what is arithmetic mean? AM. So, if A, capital A and B are in AP, then the number A, capital A, is given by A plus B by 2. And this number, capital A, is the arithmetic mean of A and B. Okay? So, the middle number is the arithmetic mean of A and B and is given by A plus B by 2. Okay? And in case of AP, where more than 3 number like A, A1, A2, AN, B are in AP, then this number A1, A2 and till AN are the n arithmetic mean between A and B. So how we can calculate this all arithmetic mean between A and B? So we calculate this by using the formula AR is equal to a plus r into b minus a by n plus 1 for all r is equal to 1 to 2 to till n. Okay, so here b is the last term of ap and a is the first term, and we can calculate all the n arithmetic mean by using this formula. Clear? And if we want to calculate the sum of all n AMs inserted between A and B, so this is equal to n times A, that is A1 plus A2 plus A3 plus till plus AN is equal to n times A plus B by 2. So what is A plus B by 2? This is the when this AP has 3 terms. So A is the arithmetic mean between A and B, that is given by A plus B by 2. So one important note, the AM, the arithmetic mean of n numbers A1, A2, comma, dot 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 AN is given by AM is equal to A1 plus A2 plus A3 plus dot 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 plus AN by n. So that's how we can calculate arithmetic mean of n numbers. Okay. Okay. So second is geometric progression, GP. So geometric progression is also a sequence in which between the two consecutive terms there must be a pattern. So what is the pattern? So it is a sequence in which the ratio of any two consecutive terms is always same. That means we can write GP as A, AR, AR square, comma dot 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 and so on. So the A is the first term of GP and AR is the second term. Then third term is AR square. So what is the pattern? That is ratio of any two consecutive terms. So if you take first two terms, so A and AR, so ratio is AR by A, that is R. And last two terms, if you take AR and AR square, so ratio is AR square by AR, so we get again R. So ratio is always R between two consecutive terms. So here A is the first term of GP and R is the common ratio. Okay, so that's how we can write a GP. And to calculate nth term of GP, that is denoted by Tn. So Tn is equal to A into R the power n minus 1. We can easily observe this formula from the sequence. The first term is A and the second term is A into R. Third term is A into R square. So nth term is A into R the power n minus 1. And if you want to calculate nth term from the end side, then Tn dash is equal to L by R the power n minus 1, where L is the last term. Okay. Now we want to add first n terms of GP. So to add, the formula is Sn. Sn is used to represent the sum of first n terms. So Sn is equal to A into 1 minus R the power n by 1 minus R, where R is not equal to 1. And it is equal to n times A when R is equal to 1. So if we take R is equal to 1, so we get A, comma A, comma A, comma A. So till n terms, so if we add them, we get NA in case of R is equal to 1. And if R is not equal to 1, so then formula is A into 1 minus R the power n by 1 minus R. Okay. So that is the sum of first n terms. In case of infinite, if mod of R is less than 1, R is the common ratio. So if mod of R is less than 1, then the sum of infinite GP, the sum of till infinite terms, is denoted by S infinity, and the formula is A by 1 minus R. Clear? So that's how we can calculate sum of GP. In case of finite, the formula is A into 1 minus r the power n by 1 minus r when r is not equal to 1, and when r is equal to 1 it is NA. And in case of where mod r is less than 1, the sum of infinite GP is S infinity is equal to A by 1 minus r. Clear? Wait for a minute. So now we practice some question based on sequence and series. Okay. So let's look at first question. So question is, if log base 3 2 comma log base 3 to the power x minus 5 and log base 3 to the power x minus 7 by 2 are in AP, are in arithmetic progression, then x is equal to, given options are 2, 3, 4 and 2 comma 3. Okay. So what is the information in this question? That is, these three numbers are in AP. So let us consider the first number A, B and C, and these three numbers are in AP. So what is the relation between these three numbers? If any three number A, B, C are in AP, then the middle term can be written in the form of A and C. That is 2B is equal to A plus C. So we can use that relation to solve this problem and we can find the value of x. Okay. So try. Just use the relation 2B is equal to A plus C. So the correct answer is option B. So let's solve. Given AP is log base 3 2, log base 3 to the power x minus 5 and log base 3 to the power x minus 7 by 2, and this is in AP. So we can write the second term log base 3 to the power x minus 5 as first term plus last term, that is 2 log base 3 2x minus 5 is equal to log base 3 2 plus log base 3 to the power x minus 7 by 2. Okay, we just use the if simple formula. If A, B and C are in AP, then 2B is equal to A plus C. Now we use some property of logarithmic. So we can write log base 3 to the power x minus 5 as log base 3 to the power x minus 5 square is equal to, now here in the right hand side we can use the property of log, that is log m plus log n is equal to log mn. So we get log 2 into to the power x minus 7 by 2, and we apply both sides the anti-log. So we get to the power x minus 5 whole square is equal to 2 into to the power x minus 7 by 2. Clear? Now just take to the power x is equal to t. So we get t square plus 25 minus 10t is equal to 2t minus 7. So we get an equation in terms of t, and now we solve for t. So we get t square minus 12t plus 32 is equal to 0, and from this quadratic equation we can find the value of t. So when we factorize it, we get t minus 8 into t minus 4 is equal to 0, and from here we get t is equal to 8 and t is equal to 4, and the value of t is to the power x. So we can write to the power x is equal to 8 or to the power x is equal to 4. So we can write 8 as 2 cube and 4 as 2 square, and when we compare the power we get x is equal to 3 or x is equal to 2. So in the question we have to find the value of x. So here we get x is equal to 3 or x is equal to 2. But at x is equal to 2, log base 3 2x minus to the power x minus 5 is not defined, because if we substitute x is equal to 2, so we get log base 3 2 square, that is 4 minus 5, that is log minus 1. So log is not defined for negative. So at x is equal to 2, this term is not defined. The only possible value for x is equal to 3. Clear? So in this question, to solve this, we just use a simple concept of AP, that if A, B and C, the three terms are in AP, in the middle term B can be written as 2B is equal to A plus C. And then we apply the property of log to solve this. Clear? Now, question number 2. So, what is the question? The number of numbers lying between 100 and 500 that are divisible by 7 but not divisible by 21 is, given options are 57, 19, 38 and none of these. So in this question we have to find numbers of numbers which are lie between 100 to 500, and the number must be divisible by 7 but not divisible by 21. One important thing is, if a number is divisible by 21, then it must divisible by 7. So at first we need to calculate total number of numbers that lies between 100 to 500 and are divisible by 7. Okay, and also we calculate number of numbers that is lie between 100 to 500 which are divisible by 21, and if we subtract the total number of numbers that is divisible by 7 minus total number of numbers that is divisible by 21, we get our required answer. Okay, and it must be either 57, 19, 38 or none of these. Okay, so let's solve it. So correct answer is option C. Okay, so let's look at the solution. So the number between 100 and 500 that are divisible by 7 are, the first number which are divisible by 7 is 105, and then second number is 112, third number is 119, then 126, then till dot 490, and at the last 497. So last term number from 100 to 500 which are divisible by 7 is 497. So you just need to count all these numbers which are divisible by 7 and lies between 100 to 500. Okay, that is our goal. So if we observe here, the first term is 105 and second term is 112 and third term is 119. So the difference between first two term is clearly it is 7, and the third term which is divisible by 7. So when we add 7 to 112, we get 119, that is divisible by 7. So the difference between 112 and 119 is 7. So this satisfies the condition of AP. So this sequence is a arithmetic progression. So now we can apply all the property and formula of AP in this sequence. Why? Because this is an AP. Clear? So we have to count the number of numbers for on this sequence. Okay, so we just need to calculate the value of n. So let such number be n. What is n? N is the number of numbers which are divisible by 7 and lies between 100 to 500. So as we know, the value in a AP, the nth term, that is denoted by Tn, is given by the formula a plus n minus 1d, where a is the first term and d is the common difference, and we have to find the value of n, and here the last term in the above sequence is 497. So we get Tn is equal to 497. So 497 is equal to the first term in the sequence is 105, that is the value of a. So 497 is equal to 105 plus n minus 1 into d. What is d? The common difference between two consecutive terms is always 7. So it is 7. Okay. So from this equation, we can find the value of n. Okay. So when we simplify it, we get n minus 1 is equal to 56. That is n is equal to 57. Okay. So the number, to total 57 numbers that lies between 100 to 500 and are divisible by 7. Now what is second task? Now we calculate numbers between 100 to 500 that are divisible by 21, and that are the first number is 105. So this number is also divisible by 21. Okay. The second number is 126. Then next number is 147, and the last number that is lies between 100 to 500 is 483. So this is all the number that lies between 100 and 500 and divisible by 21, and clearly it is an AP, and the difference between two consecutive terms is 21. So we can apply the formula of AP here in the same way. So let such number be m. So by using the formula of Tm, we get last term is 483. So the value of Tm is 483 is equal to a plus m minus 1 into d. So here the first term is 105. So 105 plus m minus 1 into 21, that is 18 is equal to m minus 1. So m is equal to 19. Clear? So there are total 19 number which are divisible by 21 and lies between 100 and 100 to 500. So required number. What is the required number? We have to count number of numbers that is lie between 100 and 500 that are divisible by 7 but not by 21. So just need to subtract n minus m, that is a required number, that is 57 minus 19 is equal to 38. So 38 is the number of numbers that is divisible by 7 but not by 21. Clear? So 38 is the correct answer. Shivam, clear? So, question number 3. So, if 100 times the 100th term of an AP with non-zero common difference equals the 50 times its 50th term, then the 158 terms of this AP is, options are minus 150, option B 150 times its 58 terms, C 150, and D 0. Okay, so in this question we are asked for 158 term of this AP, and there is a condition that 100 times the 100th term is equal to 50 times its 58 terms, and the common difference is non-zero. Okay, okay, 0. So correct answer is option D, that is 0. Okay, so let's start the solution. So let A be a first term and D, as it is given non-zero common difference, so D is not equal to 0, be the common difference of given AP. Okay, then what is the 100 terms of AP? So the formula for Tn is equal to A plus n minus 1 into D. Here the value of n is 100, so we get A plus 100 minus 1 into D, that is A plus 99D. And the 50th terms is T50 is equal to A plus 50 minus 1 into D, that is A plus 49D. And we need to calculate 158 terms. So T150 is equal to A plus 150 minus 1 into D, so is equal to A plus 149D. So according to question, in the question there is a condition that is 100 times the 100th item term of an AP is equal to 50 times its 50th terms. So we get 100 times of 100 terms. So 100 into T100 is equal to 50 times its 58 terms. So 50 into T50. So just substitute the value of T100 and T50 that we already calculated. So we get 100 into A plus 99D is equal to 50 into A plus 49D. Now solve this. So we get 2 into A plus 99D is equal to A plus 49D. And from here we get 2A plus 198D is equal to A plus 49D. So A plus 149D is equal to 0. Okay, and from here we clearly observe what is the value of T100 150. So T150 is equal to A plus 149D, and the value of A plus 149D is equal to 0. So the 158th term of AP is 0. Clear? Any doubt? Okay, so question number 4. So if A1, A2, comma, dot dot dot, AN plus 1 are in AP, then 1 by A1 A2 plus 1 by A2 A3 plus dot 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 plus 1 by AN plus 1 is. So we need to calculate the value of this sum, and given options are, option A is n minus 1 by A1 n plus 1, option B 1 by A1 n plus 1, option C is n plus 1 by A1 into n plus 1, and option D is n by A1 into n plus 1. So one important thing is the sequence is in are in AP, that is A1 A2 dot 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 AN plus in are in AP. So we can use the formula and result of AP to try to figure out this summation. Okay. Option C. In a AP, the common difference is always same. Okay. So if there is any conjugative terms, then difference of two conjugative terms is always same. So try to use that concept to find the summation. That is A2 minus A1 is equal to A3 minus A2 is equal to AN plus 1 minus AN, that is always D. So we use this concept to find the summation. So correct answer is option D. Okay. So let us start the solution. Let D be the common difference of given AP. Okay. And let the summation is S. So S is equal to 1 by A1 A2 plus 1 by A2 A3 plus dot 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 plus 1 by AN plus 1. Okay. So we need to calculate this summation. So just multiply numerator and denominator by D. So D by D into 1 by A1 A2 plus 1 by A2 A3 plus dot dot plus 1 by AN in AN plus 1. So we get S is equal to 1 by D bracket D by A1 A2 plus D by A2 A3 plus dot 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 plus D by AN plus 1. So as we know, the difference between any two consecutive terms in AP is always same, that is D. So we can replace D by, for the first term, A2 minus A1, because in the denominator there is A1 A2. For the second term, in the denominator there is A2 A3, so we write D as A3 minus A2, and for the last term we write D in the term of AN plus 1 AN. So we get AN plus 1 minus AN by AN into AN plus 1. So we get 1 by D bracket A2 minus A1 by A1 A2. So A2 by A1 A2, A2 A2 cancel out, we only get 1 by A1 minus A1 by A1 A2, so we get 1 by A2 plus, for the second term we get 1 by A2 minus 1 by A3, and for the last term we get 1 by AN minus 1 by AN plus 1. So in this we can cancel out minus 1 by A2 plus 1 by AT, because one with negative and one terms with positive. In the same way we can cancel out 1 by A3, because there is one terms with negative, that is minus 1 by A3, and in the third term there is 1 by A3 with positive, so we can cancel out also 1 by A3. In a similar way 1 by AN is also cancel out, so we only left with 1 by D, the first term 1 by A1, and all the terms still A1 by AN is cancel out, because one is present with negative and one term is present with positive. So we get 1 by A1 minus 1 by AN plus 1. Okay. So from here we get 1 by D into AN plus 1 minus A1 by A1 into AN plus 1. Okay. We also know that we can write AN plus 1 in terms of first term and common difference. So we get, as you know, AN is equal to A plus N minus 1 D. So AN plus 1 is equal to A1 plus ND minus A1 by, in the denominator, A1 AN plus 1. So from here A1 is cancelled out, we get ND by A1 AN plus 1, and also D is cancelled out, so we get N by A1 into an plus 1. Clear? So that is the summation of this term. Okay. So S is equal to n by a1 into an plus 1. Clear? Okay. So next question. Question 5 is, a man arranges to pay off a debt of 3600 by 40 annual installments which are in AP. When 30 of the installment are paid, he dies, leaving one third of the debt unpaid. The value of the 8th installment is, okay. So total debt is 3600 and he wants to pay by 40 annual installment. And one important thing is the installments are in AP. Okay. So the summation of all installment, all 40 installment must be 3600. Then he pay off a debt when, and condition is when 30 of the installment are paid, he dies. And total, he leaving one third of debt is unpaid. So in the last 10 installment, he need to pay one third of the debt. And we ask for what is the value of the 8th installment. Okay. So here we also we use the concept of AP because installments are in AP. So let's figure out. Now, as the installments are in AP, so when we sum all the installments, all the 40 installment, the sum must be 3600, the total debt value. So the 3600 is equal to, what is the formula for summation of AP? Sn is equal to n by 2, 2a plus n minus 1 into d. And here summation value is 3600 and number of installment, that is number of terms in AP is 40. So you get 40 by 2 into 2a plus n minus 1d, that is 40 minus 1 into d. So here, from here we get 3600 is equal to 20, 2a plus 39d. Clear? So when we simplify it, we get 180 is equal to 2a plus 39d. Consider it as equation number 1. So now we have an equation for a and d. A is first term and d is common difference. And to calculate we have to calculate the value of 8th installment, that is 8th term of AP. And to calculate any term of AP, we need the value of first term and the common difference. So then by using the formula of n is equal to a plus n minus 1d, we can easily calculate. So now we have an equation in a and d. Now, when 30 of the installment are paid, he dies, leaving one third of the debt unpaid. So after 30 installment, one third of debt is unpaid. And what is the one third value of debt? That is 3600 by 3, that is 1200. So 1200 is unpaid and 2400 is paid by 30 installment. So one important thing is 2400 is paid by 30 installment. So if we sum first 30 installment, then the value is 2400. So when we again use the formula of summation for 30 installment, so we get 2400 is equal to, now the value of n is 30. So we get 30 by 2, 2a plus 30 minus 1 into d. So we get 160 is equal to 2a plus 29d. So consider it as equation number 2. So now we have two equations for a and d. So we can solve this two equation to find the value of a and d. So on solving equation 1 and 2, we get A is equal to 51 and D is equal to 2. So now we have value of A, the first term of AP, that is 51, and the common difference of AP is D. So we can easily calculate any installment. So we need to calculate 8th installment. So the value of 8th installment is equal to A plus n minus 1D. And in case here n is 8, so we get A plus 8 minus 1 into D. That is 51 plus 7 into 2. That is 65. So 65 is the value of 8th installment. Okay. Any doubt? Next question. So in question 6, A1, A2, A3 and so on be an AP. Okay, such that A1 plus A2 plus dot 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 plus AP by A1 plus A2 plus A3 plus dot 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 plus AQ is equal to P cube by Q cube. Okay, where P is not equal to Q, then what is the value of A6 by A21? Okay, so important thing is this sequence is in AP. So we can sum the numerator and denominator of this relation, that is A1 plus A2 plus dot dot AP, and by A1 plus A2 plus A3 plus dot dot AQ is equal to P the power 3 and Q the power 3. So here we can apply the formula of summation of AP and just try to figure out the value of A6 by A21. Given options are, option A is 41 by 11, option B is 121 by 1681, option C is 11 by 41 and option D is 121 by 1861. Clear? So just use the formula of summation of AP, that is Sn is equal to n by 2 2a plus n minus 1 d. So the correct answer is option B. So let's start the solution. So given that A1 plus A2 plus dot 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 plus AP by A1 plus A2 plus dot 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 plus AQ is equal to P the power 3 by Q the power 3. So here we can apply the formula of summation of AP, that is, here the value of n is P, as a summation Sn is equal to n by 2 2a plus n minus 1d. For the numerator part n is P, so we get P by 2 2a1 plus P minus 1 into d, and when we sum the denominator part we get Q by 2 2a2 plus Q minus 1 d and is equal to PQ by QQ. Okay, where d is the common difference of AP. So when we solve it, we get 2a1 plus P minus 1d by 2a2 plus Q minus 1d is equal to P square by Q square. That is a1 plus, just take 2 as common, so you get a1 plus P minus 1d by 2 by a2 plus Q minus 1d by 2 is equal to P square by Q square. Now we have to calculate the value of A6 by A21. So we put P is equal to 11 and Q is equal to 41. So we get A1 plus 11 minus 1 d by 2 by A2 plus 41 minus d by 2 is equal to 11 square by 41 square. We just take P is equal to 11, Q is equal to 14. Why? Because the formula for A6 is equal to A1 plus 5d, and for A21, A2 plus 20d. So from here we get A1 plus 5d by A2 plus 20d is equal to 121 by 1681. So A1 plus 5d is A6 and A2 plus 20d is A21. So A6 by A21 is equal to 121 by 1681. Okay. So that is the value of A6 by A21. Clear? Okay. Now, next question. A person is to count 4,500 currency notes. Let AN denotes the number of notes he counts in the nth minute. If A1 is equal to A2 is equal to dot 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 is equal to A10 is equal to 150 and A10, A11 and so on are in AP with common difference -2, then the time taken by him to count all notes is option A is 24 minutes, option B is 34 minutes, option C is 125 minutes, and option D is 135 minutes. We can choose the value P11 and Q41 by the formula of A6 and A21. Okay, because for A6 we need A1 plus 5d, that is 11 minus 1 by d by 2. So from there we can get the value 5, and to get 20 we substitute 41. Clear? So in this question we need to count 4,500 currency notes. Okay, and AN denote the number of notes he counts in nth minute. So A1 denote the number of notes that he count in first minute, and it also given that A1 is till A10 is equal to 150. So till first 10 minutes, in each minute he count 150 notes. Okay, and from A10 the number of notes counts A10, A11 are in AP with common difference is -2. So in the minute A11 he counted 148 notes because the common difference is -2. Then we have to count, then the time taken by him to count all notes is option are 24 minute, 34 minute, 125 minute and 135 minute. Clear? So correct answer is option B. So let's solve. Now, number of notes that the person counts in 10 minutes is equal to 10 into 150, because in the question there is given that in the first 10 minutes, in each minute he counts total 150 notes. So total number of notes that he count in first 10 minutes is equal to 10 into 150, that is 1500. So total 1500 notes he count in first 10 minutes. And after 10 minutes, the A10, A11 are in AP. Okay, with common difference -2. So in the 11th minute, he count total 48 notes. So let n be the time taken to count remaining 3000 notes, because he already count 1500 notes and there is total 4500 notes. Okay, so we can write it as n by 2 2 into 148 plus n minus 1 into minus 2 is equal to 3000. Because the terms are in AP and we need to count total 3000 nodes, so the sum must be 3000. So we need to calculate the value of n, and the first term in AP is A11, that is 148, because A10 is 150 and are in AP with common difference minus 2. So A11 is 148. So 2 into 148 plus n minus 1 into minus 2 is equal to 3000. So we get n square minus 149n plus 3000 is equal to 0. So just factorize it. We get n minus 24 into n minus 125 is equal to 0. So the value of n is equal to 24 and 125. The first 10 minutes plus the additional 24 minutes is required to count total 4500 currency notes. N is equal to 125 is not possible because we have only 4500 currency note. Okay. So the answer is 34 minute. So correct option is option B. Clear? So that's all for today. So today we'll cover sequence and series, and we will practice some question. Manisha, clear? Okay, so let's end today's session. Thank you. Hello students, welcome to today's class. In today's lecture, we will learn about motion in a plane. This is theory part 2. Alright, this is our disclaimer. So in today's lecture, we will cover firstly uh, resolution of a vector. Then we will cover the topic relative velocity. Then third, we will study motion in a plane. In this topic, we will see that how a two-dimensional motion can be studied in the form of two independent one-dimensional motions. And last, we will discuss projectile motion. Alright. So our topic is resolution of a vector. Let's discuss resolution of vector now. The process of breaking a single vector into two or more components along different directions is called resolution of a vector. Here, that different directions may be along x-axis, along y-axis. Alright, this is a fundamental concept in physics and engineering, as it allows us to analyze complex vector quantities by studying their simpler parts along specified directions. Consider here a vector A that lies in the two-dimensional xy plane and forms an angle theta with the positive x-axis. Look at figure. Here we have a x-axis and then y-axis, and the theta here with positive x-axis. To understand this effect or influence in each direction, we resolve a vector into two perpendicular components as shown in the figure. One along the x-axis and other along the y-axis. Alright. From figure, the component of a vector along the x-axis, or we can say along the x direction, denoted as ax, measures how much of the vector points horizontally. This component is calculated using the cosine of the angle theta. Specifically, ax is equal to a cos theta, where a is the magnitude of vector a. Similarly, the vector component along y direction, denoted as ay, is found using the sine of the angle. So ay equal to a sine theta. Alright, here both ax and ay are scalar values representing the magnitude of the vectors influence their respective directions, and when multiplied by the unit vectors, that is I cap along x and j cap along y, they become vector components. By adding these two perpendicular components vectorially, we reconstruct the original vectors a vector as a vector is equal to ax I cap plus ay j cap. This representation is very useful because it breaks down the vector into manageable parts that can be analyzed independently. Now we will talk about the components. So here ax is equal to a cos theta. So we can say it is the magnitude of the vector, magnitude of the component of vector a along x direction. Similarly, the component of a vector along the y direction is ay equal to a sine theta. Alright. So in short, we can say ax is equal to a cos theta and ay equal to a sine theta.
These components represent how much of the vector A acts in each of the perpendicular x and y directions. Using the triangle law of vector addition, the magnitude of the original vector A can be determined from its components by Pythagorean theorem. So, mod of A is equal to under root ax square plus ay square. This confirms that the vector components ax and ay correctly combine to give the magnitude of A vector. Additionally, here the angle theta that the vector A makes with the x-axis can be found by taking the ratio of the components and applying the inverse tangent function. So, tan theta equal to ay divided by ax. It leads to theta equal to tan inverse ay upon ax. This relationship helps us determine the direction of the vector based on its resolved components. This method of vector resolution is essential in solving problems involving forces, velocity, or any physical quantities that have both magnitude and direction. Clear everyone? Any doubt? Yes. Manisha? Nirjana? The resolution of vector? Clear? Okay. Any doubt? Now, let's see what is the relative velocity. This is most important topic in this chapter. All right. So now let's see what is relative velocity. Relative velocity is defined as the time rate of change of the relative position of one object with respect to another. Mathematically, the relative velocity of object B with respect to object A is given by this one. VBA is equal to VB minus VA. Here VB is the velocity of object B and VA is the velocity of object A. Alright, and their relative velocity will be VBA. There are different cases depending on the directions of motion of two objects. If we talk about the case first, so we can say when objects A and B move along parallel straight lines but opposite directions as shown the above here. The magnitude is same but the direction is opposite. The relative velocity of B with respect to A is calculated as VA is equal to VB minus of VA is equal to VB plus VA. This is because the velocity of A is in the opposite direction. So, subtracting a negative velocity effectively adds the magnitudes of the two velocities. So, it will be VB plus VA. If we talk about the case second, so we can say when both objects move along parallel straight lines in the same direction the relative velocity of B with respect to A is simply the difference of their velocities. So VBA is equal to VB minus VA. Here, uh, since both velocities are in the same direction, so we subtract to find how fast B is moving relative to A. Understanding relative velocity in these scenarios is crucial for analyzing motion in physics, such as in collision problems or when observing moving objects from different reference frames. Let's see case third, crossing the river. In this case of crossing a river straight across from one bank to opposite bank, the swimmer must compensate for the water flow of the river to ensure the path is perpendicular to the river banks. To achieve this, the swimmer should head upstream at an angle theta relative to the direct lines across the river, denoted as OB in the diagram. Alright. Here OB represents the direction of the resultant velocity VMR, which is the vector sum of the swimmer's velocity relative to the river Vm and the velocity of the river current Vr. Alright. So according to Pythagorean theorem for velocities, the swimmer's speed squared is equal to the sum of squares of the resultant velocity, and the river's velocity Vm square is equal to V square Mr plus V square R. So from the right triangle, triangle OAB, with O is the starting point, A is the point directly across the river, and B is the end point. Alright, B is the end point reached by the swimmer due to the river current, and the angle theta satisfy the relation. So sin theta equal to VR divided by Vm. Alright, so this helps find the effective velocity of the swimmer across the river perpendicular to the banks, as VMR is equal to under root Vm square minus Vr square. Now we will talk about the time. So the time taken to cross the river, which has a width d, is then given by the distance divided by the effective velocity across the river. So t equal to d divided by VMR, which is equal to d divided by under root Vm square minus Vr square. This approach ensures the swimmers reaches the opposite bank in the shortest possible time by swimming an angle that counters the river's current. Alright, so case 3 are asked in exams many times. Any doubt here? Now let's see case 4. When a swimmer wants to cross a river in the shortest possible time. So the best strategy is to swim directly perpendicular to the river banks along the line OA. This means the swimmer's velocity relative to the water Vm is directed straight across the river. However, since the river has a current flowing with velocity Vr parallel to the banks, the swimmer's actual path will be influenced by this current, resulting in a diagonal path along OB as represented in this figure. Alright. The swimmer's resultant velocity VMR is the vector sum of the swimmer's velocity Vm and the river's current velocity Vr. In the right angle triangle OAB, where O is the starting point, A is the point directly across the river, and B is the point where the swimmer actually lands. The angle theta between the swimmer's velocity and the resultant velocity satisfy the relation, that is tan theta equal to AB divided by OA, which is equal to VR divided by VM. This means the angle theta depends on the ratio of the river's current speed to the swimmer's speed. If we talk about the magnitude of the resultant velocity, so we can say VMR is equal to under root VM square plus VR square. Alright, which is always greater than either component alone. Because the swimmer is effectively carried downstream, the actual distance traveled is OB equal to under root x square plus d square, where d is the width of the river and x is equal to AB is the downstream displacement caused by the river current. Now, the time to cross the river is then calculated as distance traveled divided by uh, the resultant velocity. So, T equal to OB divided by VMR. So, it will be under root x square plus d square divided by under root VM square plus VR square. Since the swimmer's velocity across the river is Vm, the crossing time can also be written as T equal to D divided by Vm. Alright, showing that swimming straight across minimizes the crossing time regardless of the downstream displacement. The downstream displacement x is related to the velocities and river width by the equation x, that is equal to d into VR divided by Vm, which comes from the rearranging the tangent relation tan theta equal to VR divided by Vm. This displacement means that although the swimmer reaches the opposite bank in the shortest time by swinging straight across, they will not arrive directly opposite their starting point, but will be carried downstream by the current to the point B. So these are the formulas that is important for the exam. Alright, and these formulas these formulas are booster, work as a booster for your preparation. Now we will learn motion in a plane. Let's see in detail. Let's consider an object moving in a plane and we observe its position at two different times, t1 and t2. At time t1, the object is at position A, and at time t2 it is at position B. Alright, so here OB equal to R1 and OA equal to R1 and OB equal to R2. So we choose a fixed reference point O as the origin for measuring positions. The position vectors of the object at these two times measured from the origin O are denoted by R1 and R2, alright, corresponding to points A and B respectively, as shown in the figure. Look at here in the figure. Alright. Now the displacement of the object as it moves from A to B is represented by the vector R21. Alright, which points from A to B. So according to triangle of vector addition, resultant of addition of two vectors R1 and R2, R21 can be given by R2 vector. So this can be seen from the figure easily. So here R1 and R2 are the position vectors and the displacement vector is AB, or we can say R21. This displacement vector can be expressed as the difference between the position vectors at time t2 and t1. So R21 equal to R2 minus R1. This equation simply states that the displacement is the change in position of the object over the time interval t1 and t2. Now let's see velocity. So velocity is defined as the rate of change of displacement with respect to time. For the time interval between t1 and t2, the average velocity v is given by dividing the displacement vector by the elapsed time. So v equal to r2 minus r1 divided by t2 minus t1. Its magnitude represents how fast the object is moving. Now let's focus on a particle moving in the two dimension xy plane with a constant velocity. The velocity vector can be broken down into components along the x-axis and y-axis. Now v equal to vx I cap plus vy j cap. Alright, where vx and vy are the constant velocity components along x and y axis respectively, and I cap and j cap are the unit vectors in the x and y directions. Similarly, the position vector of the particle at the initial time, say t equal to 0, is r naught is equal to x naught I cap plus y naught j cap, where x naught and y naught are the initial coordinates of the particle. At any later time t, the position vector becomes r equal to x I cap plus here y j cap, because the particle moves with uniform velocity. The coordinates x and y change linearly with time, as x is equal to x naught plus vxt and y equal to y naught plus vyt. These equations represent the equation of motion of the particle in the xy plane, or we can say they describe how the particle's position changes over time, moving at constant velocity. Components Vx and Vy starting from initial position x naught and y naught. Alright, consider a particle moving in the xy plane under the influence of uniform acceleration. Let's see the equation of motion for x and y. So the acceleration vector A can be resolved into two perpendicular components along x-axis and y-axis, as A is equal to ax I cap plus ay j cap, where ax and ay represents the constant acceleration components in x and y directions respectively. Alright, these accelerations cause the particle's velocity to change over time. At any time t, the velocity components of the particle along x and y axis, denoted by vx and vy, are related to the initial velocity components ux and uy, and the accelerations by the following linear equations: vx is equal to ux plus ax into t and vy equal to uy plus ay into t. Here ux and uy are the components of the initial velocity vector at time t equal to 0, while vx and vy describe how the velocity changes at time progresses because of the acceleration in each direction. Alright, this is clear? The acceleration and their components are clear? Manisha, VK, Sibam, Sahil, Niranjana, Narendra. Any doubt? Alright. The resultant velocity vector v at time t has a magnitude given by the Pythagorean sum of its components. So v equal to under root vx square plus vy square, which tells us the speed of the particle at that instant. The direction of the velocity vector uh, relative to x-axis is given by the angle theta equal to tan inverse vy upon vx. This angle theta helps to understand in which direction the particle is moving at time t. Now, to describe the particle's position at any time t, we use the equations of motion for each axis separately, starting from an initial position x naught y naught at time t equal to 0. The coordinates of the particle at time t are x is equal to x naught plus uxt plus 1 by 2 axt square and y equal to y naught plus uy into t plus 1 by 2 at square. These equations show that the position changes not only due to the initial velocity but also because of the acceleration, which causes the particle's motion to be curved or accelerated in the plane. Alright, so the 1 by 2 axt square and 1 by 2 ayt square here terms represents the displacement contributions due to acceleration along each axis. Alright, projectile motion. This is the most important concept for the JEE. So, everyone listen carefully, because from this concept question asked in exam again and again. Are you ready for this concept? Okay, let's discuss projectile motion now. A projectile motion, or we can say a projectile is an object that is launched into the air with initial velocity u in a given direction, and the after projection it moves freely under the influence of gravity alone, and the path traced by this object during its motion is called its trajectory. The motion of a projectile is a classic example of two-dimensional motion with a constant acceleration due to gravity acting downward. Alright. So, in shortly, we can say projectile motion is a two-dimensional motion because uh, the body is moving in along two axes, along x-axis and along y-axis simultaneously. Suppose a particle is projected from that ground at an angle theta with an initial velocity u as shown in the figure. Look at here. So this initial velocity can be resolved into two perpendicular components. The horizontal component ux is equal to u cos theta and the vertical component uy equal to u sin theta. Since there is a no horizontal acceleration, ignoring air resistance, the horizontal acceleration is ax equal to 0. However, the vertical acceleration is due to gravity and acts downward. So, Ay equal to minus g. The vertical velocity at any time t is given by Vy equal to uy minus gt, where gravity reduces the vertical component of velocity over time. At the highest point of the projectile's flight, the vertical velocity becomes 0. So, Vy equal to 0. So, using this condition, the time to reach the highest point is small t equal to u sin theta divided by g. Since the total time of flight capital T is twice the time to reach the highest point because the motion up and down are symmetric. So, total flight time is capital T equal to 2u sin theta divided by g. Alright. The equation here The equation of projectile trajectory describes the vertical position y as a function of horizontal position x and is given by y equal to x tan theta minus g divided by 2u square cos square theta into x square. This equation represents a parabola, showing that the projectile's path is curved due to the effect of gravity. Alright, this is clear? Yes or no? The maximum vertical height h reached by the projectile can be found by considering the vertical motion and is given by h is equal to u square sin square theta divided by 2g. The horizontal range r, which is the total horizontal distance traveled by projectile before it hits the ground, is the product of horizontal velocity and the total time of flight. So r equal to ux into t, which is equal to u square sin 2 theta divided by g. Alright. So the range depends on the sine of the twice of the projection angle, and the maximum horizontal range occurs when sine 2 theta is maximum, which happens at 2 theta equal to 90 degree or theta equal to 45 degree. Thus, the projectile achieves its greatest horizontal distance when launched at a 45-degree angle. Alright. So here, as a conclusion, we can say projectile motion combines uniform horizontal motion with uniformly accelerated vertical motion under gravity, resulting in a predictable parabolic trajectory characterized by these key equations and properties. Alright. Any doubt? Let's look at the projectile motion in horizontal direction from the height. Consider a particle projected horizontally with an initial speed u from a height h above the ground. Since the particle is projected horizontally, its initial vertical velocity is 0, and it starts to fall freely under the influence of gravity as represented in the figure, in this figure. Alright. So the horizontal motion occurs with constant velocity u because there is a no horizontal acceleration, while the vertical motion is uniformly accelerated due to gravity with acceleration small g. The equation of projectile's trajectory describes the vertical displacement y as a function of horizontal displacement x, and it is given by y equal to gx square divided by 2u square. This shows that the path is a parabola opening downward, where the vertical displacement increases quadratically with horizontal distance, as you see in the figure. So the time of flight t, which is the time taken for the particles to fall from the height h to the ground, is determined solely by the vertical motion and is given by t equal to under root 2h divided by g. During this time, the horizontal range r, or the horizontal distance travelled by the particles before hitting the ground, is r equal to u under root 2h divided by g, which depends on both initial horizontal speed and the height from which the particles is projected. And if we talk about the speed, so we can see the speed of projectiles at any time t during its flight combines the uh, combines the constant horizontal velocity and the increasing vertical velocity due to gravity. So it is calculated as v equal to under root u square plus g square into t square. Thus, the horizontal projection from a height results in a parabolic trajectory with predictable time of flight, horizontal range and velocity at any instant, combining uniform horizontal motion and accelerated vertical motion under gravity. Let's study projectile motion up an inclined plane. These are very important for the exam. So please note down every formulas. Alright. So consider a particle projected up an inclined plane that makes an angle alpha with horizontal as shown in the figure. Alright. Initial speed u. The particle is projected with an initial speed u such that its velocity makes an angle theta with the inclined plane itself as represented in figure. Okay. So the motion of the particle is influenced by the gravity which acts vertically downward, but the analysis is done relative to the inclined plane surface. The time of flight t of the projectiles on the inclined plane is given by t equal to 2u sin theta divided by g cos alpha, which shows that the flight time depends on initial speed, the angle of projection relative to the incline, and the incline angle alpha. Alright, everyone? Manisha, VK, clear? Yes or no? Alright, let's see some more formulas. The maximum height h attained by the particles above the inclined plane is h is equal to u square sin square theta divided by 2g cos alpha, indicating that the effective vertical height is influenced by the inclined angle through the factor cos alpha. The horizontal range r along the inclined plane, which is the distance traveled by the projectile before it lands back on the inclined surface, is given by r equal to 2u square sin theta cos theta plus alpha divided by g into cos square alpha. This expression captures the combined effect of the angles theta and alpha on the range, as well as the initial speed and gravitational acceleration. So the maximum range on the inclined plane occurs when the angle of projection satisfy theta equal to pi by 2 minus alpha by 2, which balances the angle of projection and the incline to maximize the distance traveled. For this optimal angle, the maximum range Rmax differs depending on whether the projectile is thrown upwards or downwards relative to the incline. So when thrown upwards, the maximum range Rmax is equal to u square divided by g into 1 plus sin alpha. Alright. When thrown downwards, it is Rmax is equal to u square divided by g into 1 minus sin alpha. These results show that the incline angle significantly affects the projectile's motion, altering the time of flight, maximum height and range compared to the motion on a horizontal plane. So the analysis demonstrates how the interplay between the projection angle and the incline modifies classical projectile motion outcomes. Let's see some important results for projectile motion down and inclined plane now. Consider a projectile launched down an inclined plane from a point O with an initial speed u at an angle theta with the horizontal as represented in the figure. So the inclined plane itself makes an angle alpha with the horizontal. So in this scenario, the projectile motion is analyzed relative to the inclined plane surface, but gravity acts vertically downward. The time of flight t for projectile moving down the inclined plane is t equal to 2u sine theta plus alpha divided by g cos alpha, which shows that the duration of flight depends on the initial speed and the combined angle of projection and inclination theta plus alpha, the inclination angle alpha, and the horizontal range r, which is the distance measured along the horizontal direction covered by the projectile before it lands on the inclined plane, is expressed as r equal to u square divided by g cos square alpha sine 2 theta plus alpha plus sine alpha. This formula reflects how the projectile's horizontal range is influenced by the initial velocity. The angles of projection, we can say, and inclination and gravity here. The presence of cos square alpha in the denominator indicates the effect of inclination on the horizontal distance covered, while the sine terms in the numerator account for the directional components of the motion. Overall, the we can say uh, projectile motion of a projectile down an inclined plane differs from the motion on a flat horizontal surface due to the combined effects of the launched angle and the slope of the plane. All right. Thank you. Now we will solve some practice questions based on these topics. Are you ready for the questions? Yes or no? Everyone. Are you ready? Niranjana. Yogananda. Ready for the questions? Everyone. All right. So now we will solve some practice questions based on motion in a plane. This is our disclaimer. So here we will discuss some practice question based on a motion in a plane. Question first. A body is projected with a velocity v1 from the point A as shown in the figure. At the same time, another body is projected vertically upwards from B with velocity v2. The point B lies vertically below the highest point for the both bodies to collide. So v2 upon v1 should be what? So in this question you have to find out the v2 upon v1. Alright, and the angle speed projection speed is v1. Given options, option A 2, option B 0.5, option C root 3 by 2, and option D 1. So which option is correct? Please solve this question. You have some time. Yes, try to solve. Everyone. Which one is correct? A, B, C, D. So correct option is B here. So let's see the solution. Two bodies will collide at the highest point of the projectile launched from point A. If both reach the same vertical height at the same time, the highest vertical height reached by the first body is given by the formula for the maximum height in projectile motion, that is v1 square sine square 30 degree divided by 2g. The second body is projected vertically upwards from point B with velocity v2. So its maximum height is v2 square divided by 2g. Alright. So for the two bodies to collide, their maximum heights must be equal. So meaning we can say v1 square sine square 30 degree divided by 2g, which is equal to v2 square divided by 2g. Cancelling the common terms and solving for the ratio v2 upon v1, so it will be v2 upon v1 equal to sine 30 degree, or we know sine 30 degree is equal to 1 by 2. 1 by 2 means 0.5. Thus the vertical velocity v2 of the second body must be half the initial velocity v1 of the first body for them to collide at the highest point. This shows that the correct ratio is 0.5. Clear? Clear? Niranjana, Yogen, Nanda, Manisha, VK. Narendra, Niranjana. Second, a person aims a gun at a bird from a point at a horizontal distance of 100 meter. If the gun can induce a speed of 500 meter per second to the bullet, at what height above the bird must he aim his gun in order to hit it? So here you have to find out the or we can say the question asks for the height above the bird at which the person should aim the gun to ensure the bullets hits the bird, given the bullet speed and the acceleration due to gravity. Given options: option A 10 centimeter, option B 20 centimeter, option C 50 centimeter, and option D 100 centimeters. So which option is correct? Please solve this question. Okay. Anyone? Let's see the solution. So correct option is B. The gun is fired from a point O at the word located at B, which is 100 meters away horizontally. So the bullet is fired with an initial speed, initial velocity v u equal to 500 uh, meter per second at an angle theta above the horizontal. So because of the bullet follows a projectile path, the person has to aim at a height AB equal to h, alright, above the word as represented in figure to compensate for the bullet's drop due to gravity. Alright. So the horizontal range r of a projectile is given by the formula r equal to u square sine 2 theta divided by g, where g equal to 10 meter per second square is the acceleration due to gravity. Since the word is 100 meters away, so we set r equal to 100. So substituting the known values in the expression of the horizontal range, we get 500 square sine 2 theta divided by 10 is equal to 100. So rearranging this, we find sine 2 theta equal to 100 into 10 divided by 500 whole square, which is equal to 1 divided by 250, which comes nearly equal to sine of angle 40 minutes. This very small value corresponds to an angle of approximately 40 minutes. So 2 theta equal to 14 minute or theta equal to 7 minute. Next, we convert angle theta from minutes to radians, because radians are the SI unit for angle measurements in calculations. Since 1 degree equals 60 minutes and pi radians equal 180 degrees, the conversion gives theta equal to 7 divided by 60 into pi divided by 180 radians. Alright. Now, to find the height AB at which the person must aim, we use the small angle approximation, where the angle in radians equal to the ratio of the arc length to the radius. So here arc length corresponds to the height AB and the radius corresponds to the horizontal distance OB. So OB equal to 100 meters, therefore theta equal to AB divided by OB. So this implies AB equal to theta into OB. So substituting the values, we have AB equal to 7 divided by 60 into pi divided by 180 into 100 meters. So converting this height into centimeters by multiplying by 100, since 1 meter equal to 100 centimeters. So AB we equal to 20 centimeter. This means the person must aim 20 centimeters above the word to compensate for the bullet's drop and successfully hit the target. Alright, clear? Yes or no? Next one. A cannonball has the same range r on a horizontal plane for two angles of projection. If h1 and h2 are the greatest heights in the two paths for which this is possible, then given options a r equal to h1 h2 whole power 1 by 4. Option B, r equal to 3 into root h1 h2, and option C, r equal to 4 into under root h1 h2, and option D, r equal to under root h1 h2. So which option is correct? Think about it and please try to solve this question. You have some time. Everyone. Mayank, Niranjana, VK, Yogananda, Niranjana, Manisha. Yes, please solve. So correct option is C. When a cannonball is projected on a horizontal plane, it achieves the same horizontal range r for two different angles of projection, theta and 90 degree minus theta. The maximum heights reached in these two paths are denoted by h1 and h2. The height h1 for the angle theta is given by the formula h1 equal to u square sine square theta divided by 2g, where u is the initial velocity and g is the acceleration due to gravity. Similarly, for the complementary angle 90 degree minus theta, the maximum height h2 is h2 equal to u square sine square 90 degree minus theta divided by 2g, which is equal to u square cos square theta divided by 2g. Multiplying these two heights together, we get h1 h2, which is equal to u raised to the power 4 sine square theta cos square theta divided by 4g square. This expression can be rewritten using the identity for the horizontal range r equal to u square sine 2 theta divided by g, which implies r equal to 2u square sine theta cos theta divided by g. So substituting the and rearranging, it follows that h1 h2 equal to 1 by 4 into r square by 4. So taking the square root and solving for r, we find the relationship r equal to 4 into under root h1 h2. This formula elegantly connects the horizontal range of the projectile with the geometric mean of the maximum heights reached in the two different trajectories. Next one. A projectile is thrown in the upward direction, making an angle of 60 degree with horizontal direction with a velocity of 147 meter per second. Then the time after which its inclination with the horizontal is 45 degree is what? Given options: option A 15 second, option B 10.98 second, option C 5.49 seconds, option D 2.745 seconds. So which option is correct? Think about it and please try to solve this question. Everyone, you have some time. Which one is correct? Let's see the solution. So correct option is C. To solve the problem, we begin by analyzing the components of the velocity at the initial angle of 60 degree. And At the later time, when the projectile's velocity vector makes an angle 45 degree with the horizontal component of velocity remains constant throughout the projectile's motion because there is no acceleration in the horizontal direction. Therefore, the horizontal component of the velocity at 60 degree is equal to the horizontal component of velocity at 45 degree. Mathematically, this is expressed as u cos 60 degree equal to v cos 45 degree, where u equal to 147 meter per second is the initial velocity and v is the velocity magnitude when the angle is 45 degree. So equation implies 147 into 1 by 2, which is equal to v into 1 divided by root 2. So substituting the values, we find v equal to 147 divided by root 2 meter per second. Next, we consider the vertical components of the velocity. The initial vertical component is uy equal to u sine 60 degree. After substituting all the values, uy equal to 147 root 3 divided by 2 meter per second. So the vertical component at the time when the angle is 45 degree is vy equal to v sine 45 degree. After substituting the values, vy equal to 147 divided by 2 meter per second. All right, clear? So since the gravity acts downward with acceleration a equal to minus 9.8 meter per second square, the vertical velocity changes over time according to vy equal to uy plus at. So put the values here and you will be get 147 divided by 2 equal to 147 root 3 divided by 2 minus 9.8 t. So rearranging this equation to solve for t, we get 9.8 t is equal to 147 divided by 2 into root 3 minus 1. So we find that the time after which the projectile's velocity vector makes an angle 45 degree with the horizontal is t equal to 5.49 seconds. Alright. Next one. A projectile projected with a velocity u equal to at an angle theta equal to theta passes through a given height h 2 times at t1 and t2. Then given options: option A, t1 plus t2 equal to capital T time of flight; option B, t1 plus t2 equal to capital T divided by 2; option C, t1 plus t2 equal to 2t; and option D, under root t1 t2 equal to capital T. So which option is correct? Think about it and please try to solve this question. So correct option is A here. Let's see the solution. For a projectile launched with an initial velocity u at an angle theta to the horizontal, the height h of the projectile at any time t is given by the equation h is equal to u sine theta t minus 1 by 2 gt square, where g is the acceleration due to gravity. Rearranging this equation leads to a quadratic forms in terms of t, so it will be gt square minus 2u sine theta t plus 2h equal to 0. So solving this quadratic equation using the quadratic formula gives two solutions for the time that is given by the equation. Alright. So t equal to 2u sine theta plus minus under root 4u square sine square theta minus 8gh divided by 2g. This solution corresponds to the two moments when the projectile passes through the height h. Then these times are t1 equal to 2u sine theta plus under root 4u square sine square theta minus 8gh divided by 2g, and t2 equal to 2u sine theta minus under root 4u square sine square theta minus 8gh divided by 2g. So adding these two times together simplifies to t1 plus t2 equal to 2u sine theta divided by g, which is exactly the total time of flight capital T of the projectile. Thus, the sum of the two times at which the projectile passes through the same height equals the total time it remains in the air. Next one. So, a particle is projected at angle of 60 degree with the horizontal having a kinetic energy K. The kinetic energy at the highest point is what? So, here you have to find out the kinetic energy at the highest point. Given options: option A K, option B 0, option C K by 4 and option D K by 2. So, which option is correct? Please solve this question and try to solve this. You have some time. Alright, please solve. So, correct option is C. Let's see the solution. So, at the highest point of the particle's trajectory, the vertical components of its velocity becomes 0 because the particles temporarily stops moving upward before descending. However, the horizontal component of the velocity remains unchanged. Alright, throughout the motion, since there is no acceleration in the horizontal direction, assuming air resistance is negligible. The kinetic energy at any point depends on the square of the particle's velocity. So, since the only horizontal components of the velocity exist at the highest point, the kinetic energy there is based on this horizontal velocity component. If we talk about the mathematically, kinetic energy is equal to 1 by 2 mv square cos square theta is equal to uh, k cos square theta. So, the kinetic energy at the highest point is equal to the half of mv square cos theta, which results in cos square theta, the initial kinetic energy, time into initial kinetic energy. So, for a projection angle of 60 degree, cos 60 is equal to 1 by 2. So, squaring this gives 1 by 4. So, the kinetic energy at the highest point is k by 4. So, this is our correct answer. Good. Good, Niranjana. Next one. A boy playing on the roof of a 10-meter high building throws a ball with a speed of 10 meter per second at an angle of 30 degree with the horizontal. How far from the throwing point will the ball be at the height of 10 meter from the ground? Take g equal to 10 meter per second square, sin 30 degree equal to 1 by 2 or cos 30 root 3 by 2. Alright. So, given options: option A 5.20 meter, option B 4.33 meter and option C 2.60 meter and option D 8.66 meter. So, which option is correct? Everyone, please try to solve this question. You have some time. So, correct option is D. Look at here. Figure represents the scenario described in the question. A particle is thrown from point O, which is 10 meter above from the ground at an angle 30 degrees, and after following parabolic trajectory it touches the ground, and P is the position of the particle above 10 meters from the ground when it is going downwards after reaching maximum height. The equation shows the calculation of the range OP of a projectile launched from the ground. So, the Range formula used is r equal to u square sine 2 theta divided by g, where u is the initial speed and theta is the angle of projection and g is the acceleration due to gravity. Alright. So in the case, the initial speed is 10 meter per second, the angle is 30 degrees and g is 10 meter per second square. So substituting these values into the formula, we calculate the range as 10 square into sine 2 into 30 degree divided by 10. Alright. So solving this, you will be get OP. Since sine 60 is equal to root 3 by 2, this simplifies to 100 into root 3 by 2 divided by 10, which is equal to 5 root 3, which is approximately 8.66 meters. This result represents the horizontal distance traveled by the ball when it returns to the same height from which it was projected. Alright. Next one. A ball projected from the ground at an angle of 45 degree just clears a ball in front. If point of projection is 4 meter from the foot of the ball and ball strikes the ground at a distance of 6 meter on the other side of the ball, the height of the wall is what? So in this question, you have to find out the height of the wall based on the information. Given options: option A 4.4 meter, option B 2.4 meter, option C 3.6 meter and option D 1.6 meter. So students, which one is the correct? Think about it and please try to solve this question. Yes, Niranjana, Mayank, VK, Manisha. Which one? Yes, please. Which one is the correct option? Mayank? Yes, which one is? Let's see the solution. So correct option is B. Okay. Here figure describes the scenario given in the question. The angle is 45 degree and velocity is v. So the solution begins by the using the range formula. All right. So we know the formula of the range: r equal to u square sine 2 theta divided by g, where u is the initial velocity, theta is the angle of projection and g is the acceleration due to gravity. Since the ball lands 6 meters beyond the ball, that is 4 meters away, the total horizontal distance covered by the ball is 10 meters. Given the projection is 45 degree. We know sine to theta is equal to what in that case? So here theta is 45 degrees. So sine to theta is equal to sine 90. It means it is equal to 1. So the formula simplifies to range r equal to u square divided by g. Using the range of 10 meters, u square comes equal to 10 g. So u equal to 10 meter per second as g equal to 10 meter per second square. Next, the height of the ball when it is at the position of the ball 4 meters from the projection point, it is calculated using the projectile height at any particular horizontal distance. So y equal to x tan theta minus gx square divided by 2u square cos square theta. Alright. So substituting x is equal to 4 meters, theta equal to 45 degree, here g equal to 10 meter per second square, equation becomes y equal to 4 tan 45 degree minus g into 16 divided by 2u square cos square 45 degree. So using u equal to 10 meters per second, then tan 45 degree equal to 1 and cos square 45 degree equal to 1 by 2. So the height at the ball is computed as y equal to 4 into 1 minus 10 into 16 divided by 2 into 10 into 10 into 1 by 2. So finally, after calculating, we get y equal to 4 minus 1.6, which is equal to 2.4 meters. Thus the height of the wall that the ball just clears is 2.4 meters. Neglecting the air resistance, the time of flight of projectile is determined by what? Given options: option A u vertical, option B u horizontal, option C u equal to u square vertical plus u square horizontal, and option D u equal to u square vertical plus u square horizontal whole power 1 by 2. So which one is correct? Here question asks about the factor that determines the time of flight of a projectile when air resistance is ignored. It represents 4 options related to the components of the initial velocity: the vertical component and the horizontal component, and the sum of the square of the vertical and horizontal components and the square root of the sum of the squares of these components. The goal is identify which of these quantities directly affects how long the projectile stays in the air during its motion. So solve this question. So correct option is A. The time of flight denoted by T of projectile is the total time it remains in the air from launch to landing. It is twice the time taken to reach the highest point of the trajectory, which is represented as T. So since vertical component of velocity is responsible for vertical displacement in a projectile, so using the vertical component of initial velocity, u sine theta, where theta is the angle of projection and the time to reach the maximum height is given by t equal to u sine theta divided by g. So using the first equation of motion where g is the acceleration due to gravity, so total time of flight is the twice uh, this value, so it becomes t equal to 2t, which is equal to 2u sine theta divided by g. So this shows that here uh, the time of flight depends directly on the vertical components of the initial velocity, which can be expressed as a u vertical is equal to u sine theta. Thus the time of flight is proportional to 2yg into u vertical. All right, good Niranjana, your option is correct. Next one, the horizontal range of a projectile is 4 into root 3 times its maximum height. Its angle of projection will be what? So here you have to find out the angle of projection. Given options: option A 45 degree, option B 60 degree, option C 90 degree, and option D 30 degree. So which option is correct? Think about it and please try to solve this question. Yes, everyone, please try to solve this question. Which one is correct? So correct option is D. Let's see the solution. Let the initial velocity of the projectile be u and it is projected at an angle theta with the horizontal. Okay. So the horizontal range of the projectile is given by the formula r equal to u square sine 2 theta divided by g, where g is the acceleration due to gravity. And maximum height reached by the projectile is given by h is equal to u square sine square theta divided by 2g. According to the problem, the horizontal range r is equal to 4 into root 3h. So we set up the equation here, this one. So substituting the expressions for r and h, we have u square sine 2 theta divided by g is equal to 4 root 3 u square sine square theta divided by 2g. So simplifying this equation, the u square and g terms cancel out, leaving 2 sine theta. Cos theta is equal to 2 into root 3 sine square theta. So dividing both sides by sine theta, we get cos theta divided by sine theta is equal to root 3. This means cot theta equal to root 3, which corresponds to theta equal to 30 degree. Therefore, the angle of projection satisfying the given condition is 30 degree. Clear, everyone? Yes or no? If you have any doubt, please ask. Yes, Niranjana. Mayank? Bhavya Singh? Any doubt? Manisha? Yes or no? All right. Okay. Okay. Thank you for your attention. So, in next lecture, we will learn laws of motion and some practice question. All right. So, are you ready for laws of motion? In next lecture, we will learn laws of motion. Clear? Everyone? All right. Thank you. Thank you for your attention, everyone.